Yeah, now we're going to cross to the other side of the rim through a small submarine channel that looks eroded there in the middle.
See an interest in the world of that, we're kind of waiting for the vessel to catch up a little bit.
So what?
If you see anything
of
worth
course.
stopping for, we're kind of waiting for the vessel to catch up a little bit, so we're kind of going a little bit slower.
Yeah.
If you do see anything you like,
Yeah, which one is it?
I mean, yeah, you can see he's happening. Yeah.
Hey, Tony. Can you bump up to point 3 and point 4?
Yeah, no, we'll do point 3 now, so I'll go to point 4.
Thank you.
All right, hi again, everyone. Looks like we're back online. I'll see you all in the chat again. My name is Tomer. I'm part of the science department for Schmidt Ocean, and with me in mission control tonight are ROV pilots Mike and Adam. Doing a great job. And members of the current science party on board, Andres, Anson, and Aaron, and Anna, and Amy. And we're going to be diving all through the night until a forecasted weather system will kind of dictate when we recover tomorrow. Probably early afternoon, local time, Chile. And address?
Okay, yes. We're going around the Chile Triple Junction. We're about several miles north of it. The Chile Triple Junction is a unique feature in the world. It's where 3 tectonic plates meet. Two of them are divided by a mid-oceanic ridge, the Chile Ridge, and this ridge is subducting under the South American continent. This configuration is currently unique in the world, so that's where we're looking here. And in this area we are looking at a small volcano what basaltic volcano looks like. And we're taking samples from it around.
Yeah. That's cool.
Another interesting feature is just something like 40 kilometers southeast of this point. We have the youngest ophiolite in the world, also, which is stuck to the continent. We believe this ophiolite is coming from the Chile ridge itself, and it got stuck into the continent something like 5 to 3 million years ago. So, again, a very interesting place, and as I said before, unique in the world.
Andres, could you tell us a little bit about yourself, your background, your affiliation, what you're interested in?
Well, I'm a geologist. I work in the National Geological Survey in Chile. I'm in charge of the Marine Geology Division. And I've been going around this area for quite a long time, since my PhD thesis. Studying pretty much the rocks around here, basaltic rocks, and some other ultramafic rocks around. Pretty much trying to understand what is the evolution of the Chile ridge for the last 3 to 5 billion years, and how this got stuck in the continent.
Ah, interesting. Have you sailed on Falcor before?
No, this is my first time to sail on Falcor, although I've been here in the area with other ships before, with the Japanese scientists and some Americans as well. But this is my first time to see the actual sea bottom on live.
Ah, yeah, with the ROV?
Yeah, with an ROV. Before we just did some piston coring and some geophysical measurements, but
Yeah.
never seen the actual seabed before. So this is really pretty interesting for me.
Yeah,
it's my first time
I
after
can
a long
imagine.
time.
Tell us more about that experience, that feeling.
You mean here? Well, it's an amazing experience. The technology that you have here on Falcor is pretty amazing, and it's allowed us to see this area like we never seen it before. We have come with other vessels, research vessels in the past, but none with the technology we're seeing here, which has allowed us, as I said before, to see the seabed for the first time. I don't think there has been another expedition in the area who has been able to see this. I think we are the first.
All right. So we've been, like Falcor, we've been working in the South Pacific, in and out of Chile, since the beginning of the year. Basically, we arrived in Valparaiso for the first time in the beginning of January 2nd. And since then, we've done a number of expeditions along the coast of Chile, but also further out west in deeper waters, along the Nazca Ridge and Salas y Gomez Ridge. What can you tell us about, in terms of the geology of those regions? How does it connect to the Chile margin and the vent systems that we're interested in here?
We believe that the areas you've seen before, from Eastern Island to the pretty much close to the continent, are product of a plume that is coming from the mantle that is interacting with the mid-oceanic ridge in the Pacific, and it produces plume with a result of a series of seamounts and volcanoes that go in a pretty much east-west direction from Easter Island to the continent.
Yeah.
From the same place, you have a microplate, and in that microplate, the eastern microplate, also the Chile ridge starts and goes pretty much in a northwest-southeast direction until it meets the continent where we are now, and it subducts under the continent. this volcanic feature not only affects the margin of the South America and Chile, but also in Argentina, where you can find pretty big basalts, and perhaps even to the Magallanes region in the southern part of the South America.
Weird is always a yes.
So the subduction of the Chile Ridge is not only a local feature with local results and implications, but also is a feature that affects the whole southern part of the South American continent.
Thank you.
You're welcome.
Sorry, thank you.
Wait, we're having some background noise here.
Right, so which jar are we hoping for? It's on 2 just now. 2's empty, so we should put it in there. Yeah.
So it looks like we're gonna focus on some sampling
Yes.
right now.
I don't know what they're sampling now. Perhaps,
Fine, because it's dedicated. I mean,
Yes.
otherwise, because if we find flow that we want is to go here.
Yeah.
So that's 1 or 2.
you are going to put it in.
Can you text him my sensor really quick? Thank you. Sorry.
Well,
To
Our sediment came in.
Yeah. Right, and then that's the flow off. We'll just suck it up real slow.
sorry.
I'll just bang it right up again. Clear the jar.
Just correct me.
So you're going to put it in number
It's weird.
7?
Late night dive watches are fun, guys. It's when you get more unhinged.
I think there is something in the future.
Sorry.
I don't know if it was. Do we have anything? Maybe it was just something we said already. Right. We just have as well.
What is it? We think it's C squared. C squared. Andres, we thought it was this guy. We are unsure now, but either way, Greg was like, it's weird. Why grab it? It has eight figures.
I would say to Greg, if it's a new species, you should give us our name.
Is it a new species? You know? Well, I hope it's a new species because it's coming right inside.
Yeah, it's low pressure.
That will be number 7 or 2.
It looks like a tulip and a jellyfish frog. I don't know what a sea squirt goes under. Is it a Nigerian? That's my guess.
The other name for it is
I see it, yeah.
yeah,
Jade Rose, is it? I think, I don't know.
We're not making any cuts right here.
Something came in, but I don't know if it was. Increased just a little bit. Yeah, it's whole, I think. Is it? Is that it? I don't even know. I think it's in there.
He's there.
Oh yeah.
I
Yeah.
just saw, yes, I saw it.
It looks flat now.
Look, but looks. Oh. Yeah, like in pieces.
Yeah,
Oh,
maybe.
yes.
Maybe it's not completely made it in one piece, I don't know. We didn't, we only sucked it up with really slow pressure. So,
Oh, there was something in the tube.
I mean, I can bump it up again if you want and just make sure that nothing else comes through. Because we were barely just sucking up enough that it went up the tube. We usually just go full
Wow.
pressure. I'll ramp it up again slightly and we'll see what we see. Ah,
There.
that's
Yes.
him.
That's it.
That's him.
Yeah, it's inside.
Yes.
Thank you. Thank you.
Section sample number 2.
So, index to.
I got a photo of what you guys were texting.
What is a fine mesh? Maybe go to 8.
Okay, so I'll just make sure that L for starboard. So go 8, you say.
Yeah, 8's course and 1 is fine, I believe.
Okay.
Now, are you guys doing DNA on that, or if we find another sample, can we double it up in jar 2?
I don't know. I don't think they do DNA on it.
They will collect some, that's just ID, and I think.
And also, if they're doing DNA from it, I think it would be fine.
Yeah,
Because
it's not-
tissue DNA would be fine.
Exactly.
It's like the microbial DNA,
Yeah.
like eDNA. That's really
So well, if we
sensitive.
find something that's delicate, we can put it in that.
I would say so.
Yeah.
I feel like for barcoding, if they get enough DNA,
So
that's
just in that
probably
double.
fine. Double up. Have you seen those memes that are like, if you watch a substation, that's something that you're or a crab running theory I have like a point of view. You're being sucked by Sebastian, suction sampler. But like, someone takes a phone, like goes underneath, and has the suction sampler coming down at you, all the cameras. I hate TikTok, but I feel like that wouldn't be my use. Or it's just the porn and the bad mom.
No, I've been there, I think I would watch it.
Ahora estamos explorando el punto triple de Chile, donde las placas de Nazca, Sudamérica y Antártica se juntan. Es una característica única en el mundo. No existe otra configuración igual, por lo menos de forma actual. Ha ocurrido en el pasado, pero actualmente es la única que conocemos. En este lugar se subduce una cadena montañosa, una dorsal oceánica, en donde estamos buscando posibles pipas hidrotermales o alguna evidencia de actividad hidrotermal. En este momento estamos explorando el borde de un volcán bastante pequeño, pero es un volcán que está prácticamente en el medio de la dorsal, muy cercano al punto triple de Chile. Yeah, we can see more below lavas with flow structures there. Al parecer este volcán es bastante basáltico. Hemos visto pilolavas, pilobrechas y algunos vidrios volcánicos alrededor que hemos muestreado para poder hacer estudios de petrología y dataciones. seeing beautiful lava tubes.
Hey Tony, just go. Let's be in there. Thank you.
So we're going up the hill again.
a nice kind of radio on that?
Yeah.
It's a super, it's kind of small. Small? Yeah. So that you're gonna come up with this one, that's interesting, because it
I'll come back to it as well.
Was that?
I'll come back to it as well.
Are you going to take a sample?
No, just a visual.
Thanks.
Can we possibly get the zoom in on the tank, the light tank stuff?
Yeah. Sponge.
Is it sponge?
As far as my invertebrate biology goes.
Probably more than mine.
Hey, Tony, I'll just go to the sleep.
Thank you.
Saludo a todos los que están conectados en este momento a YouTube, especialmente a los que aman las rocas tanto como nosotros los geólogos.
I'll land a lot of them.
Put the side camera back. It's all working. If we're not on air, can you legally play Sandstorm? Yeah. Is that so? That's not forum? Even though it's in Preston?
Altitude's very close to it.
Yeah, I don't know. It was like, I was trying not to land, but then it was like, felt like it was pulling me towards it a little bit. I didn't want to.
Maybe press it over the curve up there or something.
Yeah, maybe.
Thank you.
Yeah. Maybe just caught me a bit broadsided or something. Like, oh, I'm getting close. And like, oh. Hmm? Yeah, no, that's fine. I'm not getting pulled about now. I think it was just trying to stay away from that thing. Yeah. Get close, but not too close.
denied one direction for water.
I think it's like weird when you're flying. A big heave comes in like that. And you're like, oh.
I like how there's little handles. They work great.
Yeah.
One example of a Maryland or something.
I went to see it on Paulson or something like that.
Where was it from? Nearby. It's very cool.
Yeah, they just come there and speak to them and show me water. New species. What did you get? You have the one, right? You have the good one. You need to take it.
Hey, can we update it with
Yeah, copy that, mate.
Cheers, thanks.
No, well, I usually like between it just if we're getting all that. It keeps going. Yeah. I'm used to having it so you can just flip it back on and zoom it. So the other consoles are good to go like that, is it?
Well, if you place the line like that, it's
Sorry, but I'm
but I
writing something
don't know if
that's
that's the issue. You just took
huge,
it out and it looks like it goes to the person apart from just taking part of the line first. So I did fix it. You could drop it. In fact, you could drop it now. You could try it. But with intercepts at the bottom, just get in there. But don't try it.
I've never seen it.
Right. Just work with this just in case. Suppose it's working out. What is it? So you've got a map, all these buttons, you have to do it on software. Is that pain?
It's more just kind of software.
Was a wire joystick.
But then we opened it up and there's a wire.
Just maybe like a reference or something like that.
It could be like a ground or something as well.
Yeah.
Mark asked Judge, microbiologist, he's like, I don't know if that's microbial mat. I'm gonna ask Lisa and Greg, who's an animal, Alex, PDK or sponge. Then I'll ask geochemist, and I don't think it's mineral. No one claims it. No one seems to know what it is.
Definitely not. Probably it's not good enough well.
Definitely not.
I think it will be good if we can take a sample here.
Yeah.
A small drop sample, yes.
We'll go get a few of this guy first.
Hey guys. That's an interesting one.
I love when this is an octopus on screen. Pedro walks in within 3 minutes.
Let's just wait for
These
that.
are some in the film.
They're like spider sense.
Let's just wait for dust to come out and take a little bit of light if possible. Yeah, that's it.
Different lighting. It's a lot of darks now.
Which one is this one?
What's that? That's the mids and nuts and uppers.
Somebody told me that you guys don't have auto white balance, but I have the impression that it is an auto white balance. Or you guys are doing manually on the arm.
We do usually.
Okay. Yeah, just keep it wide for now, just to wait the dust on it, and then we push from now.
So how do you want us to do?
Yeah, let's keep it there like 30 seconds, and then we do a little cropping. While we wait for the dust to come out.
Do you want us to play with lights to see what works best? Or?
No, I'm happy with this one. I was like, at the beginning his face was a little too bright, but now it's a nice contrast. So I'm happy with this. Or at least the line.
Should waiting
Yeah,
for something.
he knows we are waiting for the dust to come out. But I don't think it's gonna get much better than that, right?
Suppose it didn't fly away as soon as you came in the room.
Thanks.
See ya. I'm out of here.
No, I was watching upstairs and I'm like, I'm gonna wait 20 seconds just to see if that thing's gonna move. I was literally on the door just waiting. Can we crop it on the eye a little bit? Then we get a little bit of the eye in the tentacle. Yeah, I'm gonna have to take a little bit of light. Yeah, that's it. There. Yeah. Take like a spot of light.
Do you want to do anything with the iris?
We could be with the iris. That might work better.
That's a flow right out of it.
Yeah, that's. I think we can keep with the light and change the iris.
Right, so that's the iris all the way open with the ISO at 250. I'll drop it down a step.
Yeah. Yeah, one more. That's it. Just leave it there for 15 seconds and then we get one of the vents, then we're good.
Just the particle go away.
You think it's gonna go away or is it like that?
I mean, it's so fine here,
Yeah.
like, it's probably going to hang around for ages. But
I would like
it might
to.
say, I mean, it's not like kicked up too much, but we're right up against a cliff face.
Mm.
So,
Can we put the camera a little bit up a little bit so we can see the vents as well? Yeah, it's up there as well. That's nice. So then we can see it breathing as well from this side. Aaron.
Yes.
Did you?
I'm already on it.
so I think, so we've got the lowers on just now. That causes the most amount of backscatter. Do you want to play with the lights and see if we can eliminate some of the backscatter?
Yeah, go for it.
Actually, I'm
I'll
drawing a
try
lie
Catholics.
because the lower is not on. The lowers is that. This has changed.
Yeah, let's
And then turn off the doors.
drop the mids.
Drop the mids.
Mids off. So now you're on lowers.
Let's
Hold
just.
on a second. Don't change it. Let's just see if it's gonna move.
Let's just lowers. Do you want to do anything with the ISO then? No,
No.
because it looks a bit whiter now.
Yeah. But I think he's changing color actually. Come on, dude. Yeah, but I have the impression you're right. The back's better distributed a little bit.
Well, see, I was because we have to change this console so it's not labeled up properly. So this is actually our lowers because this is your camera lower. So the lowers weren't on there, but
Ah, okay.
generally when we've got the lowers on, it makes the backscatter worse.
Gotcha.
Whereas it actually looks like it's reduced it a little bit here.
Can you tip it down a little bit? I think it's. Just leave it there for a second. Get him breathing.
You alright? Does it look a bit washed out now that the lowers on or what?
No, I like that. I like that because it kind of fits with the black on the background, and it's not. If you look at the Instagram, it's not crashing. So it's nice when we have this thing around 90. If it's over 90, that's when you know it's the whites are crashing. The big thing there on the left is the blacks here.
We moved a little bit there.
Can we try to move for the and see if we can get some movement? One of the arms, yeah. Let's zoom out, see which one is moving. Oh no, yeah, let's do it up and get that mess over there, yeah. Yeah, the one on the left there.
This one?
Yeah. Just yeah, let's keep it there.
There? Or
Yeah, if we can focus on that thing. Like that, yeah. There you go. Yeah, just leave it there. That's looking nice.
But we can do it. We can change it.
Can go back to.
See what we do here.
Go like this. You can do it on the wheels is easier on that control at the bottom wheel. Do us to frame up a bit.
Yeah, a little bit more to the right. Let's see what's going on. Yeah, it's moving. You can go more, a little bit more. There we go. Yeah, that's it. It's a little. Yeah, right there. It's really nice to see the pigmentation, the little dots.
Yeah.
Okay, let's make a last shot, like a zoom out, just some neat shot, and then we can just down a little bit. Yeah, to get like exactly like that, but cancel down a little bit more. Yeah, that's it. Just leave it 20 seconds there. That's great.
So I'll try one last line of configuration before we leave it.
Yep.
Just to see if we can get
If you wanna do it now?
back.
We got it.
Happy?
20 seconds, yeah.
There's PVC power. Oh yeah, that's right. That shit's.
Let's
Let's just try to lower capex. Just see if we can. Something like-
Uh,
Yeah. Yeah, the garbage.
That's a little too much. You can see there, but it's the blanks are crashing.
Yeah.
So
It's just the lowers.
I think that's the safest one. Then play with dogs. Very, very cheap. Yeah, sorry. Awesome. Thanks, guys. That looks very cool.
what exactly are we trying to focus on?
I'll go back to my paper.
Oh, any will be good. Any will be good. Just take it with where it's easier. Could be there or there. Any will do.
I recommend the dark red.
Well, we're trying to, are you wanting to sample something here?
Yeah, something like that.
The rock, I don't know if we'll be able to, I mean, we could try and break
This
some
is
off,
the dark
but,
Perhaps this one
Go with this. Pretty big.
yeah, this one up here.
or any other.
I see the one you're speaking about.
Yeah.
Oh, can we get any of them?
That was actually pretty good. Yeah.
That one is already loose.
Yeah. Our octopus friends stressed out about that. And then
Just drop.
just adjacent to it.
First they showed us some weird energy.
Stable.
Where do you want to put this? Same buy box?
No, BB3B.
BB3B. Okay.
Yeah. to reach it there, maybe landed you a bit off to the side. Unless you want to do it with the other arm, actually, maybe easier. We're putting this in BB.
3B.
Just check what's going on here again.
What was this one? BB2. I probably won't do like a biology on this one, so if it's easier to just stick it in the bin, that's also fine.
In the
Did you want to just throw it on the porch to save room?
If that's okay with this, yeah.
There's already one of them.
There's one in the rack right there.
Yeah, there's
Yeah, right.
just one down there.
Yeah.
I mean, if you can put another one, it's okay for me.
Yeah, I could put it like right in front of BB1, but down the crack there.
Okay,
Yeah.
that's
And
fine.
then if you want, like we've done this before with other science teams where we stack them like one
Yeah.
here, one here. As long as we get them in good position, they will usually stay. So if you're happy with that.
Yeah, that's
Did
fine.
you want to take a couple from this location?
Yeah, that would be better.
Let's do it.
So where are you putting it? Just in the gap?
Yeah, I'll put it like right.
Andres, this is more volcanic. Lava flow.
So just if you want to make a note, so this one is going to be left side of the tray. Just going to drop it down the crack here.
Okay. Yeah, notice. Great.
Okay, so it's behind. So I'll just
Andres, for logging purposes, is this more lava flow?
They may be similar to the other one.
What was that?
They may be similar to the ones we took before, but this is the other side of the ring.
Okay.
So
So,
chemically different, but visually the same.
okay.
the one that you just got will have another big chunk. I don't know if it's.
to see it?
Yeah.
Just a little bit. Alright, turn on lower, so just wanna make sure that I can't touch here.
That's great. Do you want to store it in the same place, right?
Yeah, so I'll put this one just a little bit to the right of it so you can
Okay.
distinguish the two based on both locations. Okay, so he's just on the.
I'm looking, where's the other one going?
Just going around to the
Yeah,
left.
maybe,
But if you porch it and look down, you should be able to see it. Yeah, there it is. Did you want one more?
Always.
Always okay.
yeah. Well, this is maybe it's off to the other side now.
Okay, just tell me how those spots are.
Oh, that's perfect.
You can't freeze this one.
If you need to do it over the porch.
I almost did it. What are you thinking?
Well, coming out with the porch. I want to need the space right next to it.
Yeah, that's why I got index rating.
So, very, very human.
front of VB.
So it kind of went like
2A.
1, 2, 3.
Okay.
Happy?
Very happy.
I'm happy. That's good.
Can you make a zoom there?
A weird pattern that
Okay. Thank you.
was that the white thing? Can we keep the lasers on for a sec, please?
Yeah.
improv that.
Yeah.
Then say definitely didn't get on the electronics.
So there's loads of functions that are near right on this. So whenever you're using the manifolds,
You have to do directly from outside.
you've got to read what's here. Because none of this matches up. Before you go pressing what you think you're pressing, double check it.
You gotta get that level maker in here.
So
But just for now, just because otherwise it's gonna be
the autofocus button doesn't work either. I don't think this guide autofocus works.
Do I have
This
to?
does your
I
sit
don't know,
down.
because otherwise zoom this one. Just zoom that white
Anything-
thing.
Which one?
Anything you think
The
you
white
know.
thing.
the sick
This one?
Yes. Then when they switch.
Yeah, I don't know what. Do you guys use this?
Yeah, it.
But it's also the valve pack. It's really not that hard. Mike's making it sound.
No, sorry, are you gonna do
He's like, if you're piloting, up is down, down is up.
It already was like that.
Left is right, right is left.
Basically, we're trying to extend this diagram tomorrow. So, like I did stacks and stuff like these are just if you can like stack some more stuff in here, rocks in here, rocks in here, more spots in here. Anyway, yeah, we've got a big rock in here. Yeah, I never even thought about that. If one has a big rock in there, one has a great spot.
Does the lock still work?
Basically,
It doesn't light up, but it does.
That one still works.
It still works, but it doesn't light up. So there's no fuse on this.
this one's
Yeah.
got,
These also don't work.
And if it does freeze, it's probably.
You know, you said you can get rid of whatever that.
just check.
It's like something to use there. When you're unicorn, there's something to get my eyes.
Where, oh, got it.
So that,
So the knob works, the light works.
the knobs will work, but offset with the methods. Anyway, that's how you know, like look at that, 0.22. And then the unicorn goes up there. There's something up in the unicorn real slow earlier on. Yeah, must be that.
What is port server, so I can get on here?
Aye, port and starboard still does it, but if you're ever in doubt, what's port in, what's port out, and also the bio boxes are back to front, so like the opposite. Back is close, forward is open. Learn adversity defines that.
Before leaving the spot, can you zoom there?
What ends up working?
Anna.
Anna. Is that not working? No, no, go for camera settings.
Yeah, that one.
Fine, I can't do like, yeah, that's fine.
Measurement and then the shot octopus earlier, so like the most interesting point you see. You get them running and watching shots.
Okay. You guys anyone what's estimate this camera?
I just found that's not working. I dropped you in the ship with them.
Yeah. I don't know if you guys test the light right now.
When they can do that, as long as I'm like, enjoy.
Yeah.
Anna. Anna.
You can issue our
Yes, thank you.
Okay.
Thank you.
Okay. Thank you.
Whenever you want to switch on here, I'm going to take the next trip, but as long as you're, I mean, supposed to be switching right now, but if you want to continue
Let's
for this,
say half an hour.
if you prefer.
Okay.
So what do you mean, like switch places?
Let's
So
go.
you get a little-
So let me know when you're out.
No, we're
Just
ready.
continue.
Yeah.
Enjoy.
Next week.
Good morning, Mr. Harris. Good morning, Mrs. Hahn.
This is a great one. So bad.
Excuse me, this speech won't go too fast. Oh, speed limit.
Goodbye.
Yeah.
If you want, I can give you the complete video. It was not in the complete one.
Alright, Bridge.
Good evening, Eric. There's something to
Evening, update. Thank you.
And I think
Do as long as you want, but I'm prepared. Like I can change. I add my own.
okay.
If you didn't see the weather, then you know you can rush it. Yeah. Stuff a lot. I didn't even know it came on yet. Yeah. The virtual is the diagram. I like those originally. That is a great question. Probably louder than you were just speaking and closer than you were just speaking. So it'll pick up all of our conversation right now, but people will hear it like whispers. But if you want people to hear you clearly, like speaking your own voice directly into the mic. Exactly. Yeah.
Oh, I see. It's the guy still on.
No, but that's how I judge them out.
Are we between 9 and 10 or are we
You're
more
between 8. We're between 8 and 9.
Yeah, so hi everybody, this is Amber from Senckenberg am Meer in Wilhelmshaven. I just took over the watch lead and I will be here for the next 4 hours trying to explain as much as possible. I'm not a biologist, although I'm more or less familiar with the fauna that we are about to see in this dive. I'm actually a geographer, so I studied more like oceanography and yeah, stuff like that, but worked in a fairly amount of time now in marine biology, so I'm super excited to be here. Yeah, for everybody who just tuned in, we are on quite a long dive, which is supposed to be until 4 in the afternoon tomorrow, and this is part 2 of the cruise that is under the term of Chilean Margin, which is a collaboration of different geologists, marine biologists, microbiologists, all different kinds of scientific goals are combined. And right now we are at the Chilean Triple Junction. We were exploring an old, or more or less geologically young volcano, which we were suspected to be collapsed, and that's also what we saw. We kind of saw a caldera that we explored. Right now we are at another ridge that is behind that volcano. We're exploring that site, and we're moving on from waypoint 8 to waypoint 9, occasionally sampling some fauna. We got a lot of rock samples in the last hours because the geologists were very keen on what we saw here. And yeah, so let's see what is coming up in the next. Something that we saw a couple of times today. This is an acorn worm. I think the term is Torquara torridae. Fairly sure about that. I've seen a couple of specimens which were almost 2-3 meters long actually. This one is more or less middle-sized, but still very nice to see. Nice colors.
That is an updated waypointer.
Thank you very much.
You are very welcome.
We see another hemichordate on the top of the frame. Below is a sea cucumber. And there's another one in the middle. but I want to see what is on top, the squishy thing. Any idea? What it is? But is it the thing that Dakota is looking for? No, it's not.
Because that is on the sediments.
Okay.
But can we collect a fragment of this coral?
Of the coral?
Yeah, a small fragment. And I think that jelly, I think she's a mollusk and probably something what you want there.
But if you want the coral in the coral quiver, then the mollusk should be on it, right? Or does it?
No, it doesn't. I mean, we can also eat the mollusk there.
Okay. So yeah. So if you could collect a piece of the coral, like grabbing is from one of the yellowish branches, or what is the best approach? Yeah, maybe try to grab it from one of more solid branch.
One of the associates without.
No, without.
One of the solid branches. Was it before the junction? When we go with, looks like 7.
7 is available,
I
yeah.
think like right
Yeah, 7. Because,
Oh no, is that a? Yeah,
yeah,
yeah.
it's perfect. Thank you.
Yourself, Mayor?
Yeah, you should go. Yeah, it's good if it's a little bit higher, so yeah. And this ship should be fine.
Forward. Starboard.
Arrowhead Bridge.
Eric, we're going to do a collection here, but you're still good to go that way.
Alright, sounds good.
Thank you. I think Chris recommended that, but Alright, let's see this one.
So, probably better since it looks like we just need to drill it there. We're just gonna come into the negative, basically sleep there. Is that what's on?
Yes, it's just the right.
Yeah.
You have Yeah, but you know, if it disintegrates, it's very fragile. It's only going to be a squishy thing. Yeah. She wants after we collected it. Okay. Yeah. Before we collect it, can we make like a close-up?
Yeah. It's cruising backwards.
And take a picture of this.
Oh, sorry, like a still. No, so like when you log it.
Yeah. I will take it. Okay. All right. Thanks.
And then other than that, just original settings.
All right. Got it.
I like that.
Oh. There it is. piece of it, and then if possible another picture when it's in the ground, in the core.
What's that texture? That's
Fish approaching. Wow. Awesome. Thanks.
We got all day. That's what you're talking to. There it goes.
And there it is. Nice.
Thank you. Wow, that was very.
In the group or what?
It was coming off very empty. Now what you get stuff.
We're in a WhatsApp group or what? The squishy thing.
Oh, that one too.
Yeah, but now it's too late, no? Yeah, I think we're fine like that. Yeah. Yeah, I think we can just all the legs are open. always. Yeah, from my perspective, we can move on to approach the next waypoint. So we are moving forward on the slope off to the next waypoint along the ridge that is north to the volcano, and we're gonna see what we're finding there. Saw a lot of volcanic outcrop earlier in the dive, and a lot of fragments of the outcrop, which is most likely rocks that disintegrated by either gravitative forces or by landslides. And now we see more or less sedimented area without any outcrop, just small, very small fragments of the volcanic rocks. And there is an octopus. Oh no? Yeah, it's one. Always nice to see. If you want to zoom in, we have the time for that. Ah, no, okay. Not today. But it's also nice to see them in action. He's not happy being in front of the camera. But thank you. It's nice.
You came for the
No, I was gonna say that I don't need it
Okay.
because it's too small for me.
He escaped twice.
I was worried that you guys were waiting for me for it. It's too different from the other ones that we're doing, so it doesn't match.
Do you want something specific? Hey.
I write that down. Okay, fine.
Hello.
Yeah, I did in the beginning, but I think at some point I will try more. Yeah, sure.
Well, see you later, Connor. We'll have a conversation. I don't know, he just left.
Okay. Who is he coming up with now? So nothing remarkable at waypoint 9. I think we can approach the next one further down the slope.
Hello everyone again on the stream. Welcome back for our late night dive stream from dive 752 with ROV Sebastian. We're on board research vessel Falcor 2. We're right now off the coast of Chile. We're about 46 degrees south and probably a couple hundred miles from the coast, maybe a little less. The water depth here is about just under 3,000 meters, or just above 3,000 if you want to see it that way. For our viewers in the US, that's about 9,000 feet, give or take. We are exploring a more volcanic kind of area that is assumed to be relatively young in geological scale. And with me in mission control right now are ROV pilots Tyler and Alex, and our dive lead is Amber Henningsen from the University of Bremen.
Hey everybody, I think that is a pygnogonid, no? Do we want that? Sorry for interrupting the conversation. Yeah. I'm gonna continue shortly. But I think to the right was a pygnogonid.
The white thing.
It was looking more like a spider. I think.
Spider, okay.
Can also be a crinoid or something. If it's a crinoid, it doesn't matter. But if it's a pygnogonid, I would like to have a close-up. If it's not too far. Okay, then don't worry about it. I mean, we already collected one, so you can continue. Yeah, thanks for the introduction, Tomer. My name is Amber Henningsen. I'm from the University of Bremen, which is in the beautiful northern part of Germany. I'm still studying in my master's program, which is geography, and we'll hope to be finishing that soon. Meanwhile, I'm working at the Senckenberg Institute in Wilhelmshaven. Should be familiar to some people. Yeah, there's mainly everything related to the deep sea, also to the North Sea. We're studying, doing a lot of collaborations with many people around the world. It's a fantastic lab with a lot of possibilities to work in. We're mainly working right now in a project that is related to deep sea mining. So we went on a couple of cruises and collected some samples, and now what we did over the last years was trying to estimate the damages of deep sea mining to macrobenthic and megafaunal organisms, and all sorts of studies related to that. Yeah, and with me is a team of two more people. Two more people. Fritz Schiller and Marleen Tam.
Perfect, thank you.
And yeah, we're super happy to be on board, doing a bit of everything. Originally, the plan was to deploy the multi-corer, which is 8 tubes corer that you send down to the ocean floor. Yeah, we're having some troubles related to weather regarding that, so we're happy to get as much push course as we can, and as you can hear now, we're also helping out with megafauna sampling or megafauna observations in the Triple Junction. There's a nice coral. Anemone, sorry. It's an anemone. Yeah, so far about me.
Thanks, Amber. So what specifically brings you out here? What are you looking for in the course?
So what are we looking for in the course is mainly myofauna, which are organisms which are, I guess, among the groups, one of the smallest faunal groups that you can get, I think, above the microbiology. That is the next group that you can absolutely not visually identify with the eye, so you mainly need a microscope to see them. And yeah, we're looking at those animals, which are mainly composed of, for example, copepods, nematodes, chinorins, some stuff like that. And yeah, being on board was more or less having also a friendship relationship with some people who are here, so that just kind of developed. And yeah, never been in this part of the ocean before. I've been a couple of times to the Pacific, but never been to South America, never been to Chilean waters. So yeah, I don't know, I'm just very excited about the very explorative component of these dives, like seeing things that are relatively unexplored, and yeah, great opportunity.
Yeah, I think the number of expeditions with visual capabilities like ROV to this region are very small.
Yeah, that also shows in the data. Like on the leg 2, you could find some publications regarding the the locations where you guys went, but everything that was below the Triple Junction, or also the Triple Junction, is fairly unstudied, especially when it comes to biology. I guess there's a couple of things regarding to geology that are quite not well studied, but at least studied. But when it comes to biology, everything is very, very new. I mean, the interesting part is that what you see here, the groups of animals, you can definitely find in other parts of the Pacific. So, for example, the abundance of ophiurites we also see basically in the middle of the Pacific, where the Clarion Clipperton zone is, where we used to work a lot. You see them there quite often. Yeah, but of course, different morphotypes of animals, and also in every habitat that we see, there's kind of a special accumulation or special diversity of animals. That's very interesting, but of course very understudied, and always interesting to estimate what the environmental factors are at a site, and what determines the variety of animals that we see.
A lot of our viewers normally, I guess right now it's pretty late for most of our audience, but many times we get asked questions about how is it possible to get into a career that gives you these opportunities for deep sea exploration. Like, what do you have to study? What do you have to know? Where do you have to be? What can you share about your path, your journey that kind of led you to deep sea work?
So yeah, I would say in my case, I don't know, everybody says when they end up in a nice work environment or they're happy with their jobs, it's kind of having a lucky shot. But I guess for my example, or for my situation, it really was like that, because I studied geography, which is a very widespread study to do, and you kind of get a glimpse of many things, especially very broad scale systems that are happening in the ocean or in the atmosphere, that you kind of get lost in what you actually want to do. So I just 3 years ago I really felt like I want to have some practical experience, and what I did then in Germany, there's a lot of institutions, especially in the northern part of Germany around Bremen or Wilhelmshaven or Oldenburg, who are affiliated to going on cruises, really, because we have a lot of institutions like the Marum or the AVI, Alfred Wegener Institute, where going on cruises is a big part of the work. So I felt like giving that a shot and doing that. So I applied for a relatively random cruise, which I got accepted for. And the funny thing is that back then we needed a US-American visa. So I got that, which then led me to a very lucky situation of a friend being at my place and asking me if I want to join another expedition, because around that time there was COVID. I think COVID was not the beginning of the pandemic, but around then. So some people were having issues with coming on board, and they were looking for people, but they specifically needed people with a US visa. So I said, yeah, of course, let's go. And then I went to an expedition to the Clarion-Clipperton zone related to deep sea mining, and I met my boss there, and we got along super well. And I think a critical thing is, especially as a young person, is just being super open to any experience that comes up. So like being very, very open, very interested, and fascinated by the things you see or you study, and taking a lot of opportunities. And if your boss asks you if you want to do this and that, you always say yes, yeah, I want to do this. So yeah, I kind of stuck to that because my work environment is super nice. We all get along very well, and yeah, this kind of just went on and on. Interesting opportunities, and after all, I feel extremely lucky to be in the position where I am right now, especially being having a path to go. Of course, the path always changes, and you get new opportunities. Your way is kind of going somewhere, but it's really great to be having this opportunity in a practical work environment. So yeah, long monologue, but now you know.
No, that's a great answer. I think you have a very practical approach, and also like very grounded. Like you said, especially for young, kind of early career scientists, it's important to gather a broader base of experience and things that are not necessarily exactly what they imagined.
Mm-hmm. Yeah.
And that really opens up, kind of multiplies the opportunities, the number of opportunities that are available to you.
Exactly. Yeah. Yeah, and that kind of shapes the idea of where you want to go. You study and you learn theoretically about many things, but what you really want to do is something that you learn along the way. At least for my situation.
Yeah, 100%. So what's on the horizon for you? What happens after this?
So actually, I will participate in the cruise, not the cruise right after, but the cruise that comes after the cruise in between. It's the one where we are going to the Antarctic. So I'm gonna join that too. I will also stay in Chile in between and take the opportunity to travel and see as much as possible. But also, of course, rest a bit after the cruise.
Yeah.
It's Christmas time, and you just feel like after the cruise you feel like you need your bed for a couple of days and just chill and enjoy. And after that I'm still working for my company. It's part-time company. My contract is part-time. And I still need to write my master thesis, so that's going to be something, and I hope to do that with megafauna tracks that we do on this cruise together with Sophia.
Oh, nice.
Yeah, and then I don't know. I will see where it's going. Actually, there's a couple of things that can happen. Nothing fixed yet. So
very cool. What can you share about your experience on Falkor so far?
Compared with other cruises, it's very versatile because the cruises I've been on was more or less. Oh, there's a nice formation. That's cool. You see corals and a sponge, I believe. It's nice. Finally something. But you can carry on. So yeah, the cruises I've been working on, they were mostly really fixed shifts. So you were working from 12 to 12 or whatever, 6 to 6. Which is not the case here because we work with the gears and with whatever comes up. So this is definitely more, in terms of that, requiring more flexibility. And for example, like right now, this is my first time talking to any audience or like annotating anything. So that's nice. That's super cool. There we have another kind of the same coral we sampled before. Yeah, a lot of sea pens, sea feathers, sea feathers, a coral. I think in the back is a crinoid. More corals, yeah. As you see, I'm not a biologist. I'm trying my best. Yeah. Yeah, but I guess you gathered a lot of experience on all the dives and kind of have a very trained eye for what you see, no?
Yeah.
Yeah, I can imagine. Yeah, I'm actually quite not overwhelmed. I mean, it's a super nice thing to see, but compared to what we've worked on, so we mainly worked in depths of 6,000 to 7,000 meters. With, I don't know if the viewers or you, Tomer, know manganese nodules.
Yeah.
So that's mainly the target area where we have been in the last years. And you see very little topography changes. You see some sea mounds, but beside of that, it's very flat in the Clarion-Clipperton zone, and you see whatever, sea urchins, sea cucumbers, brittle stars, but it's definitely not that you have these hotspots of rock outcrop here, where things are gathering to filter. I think that's always a very nice assemblage of animals.
Yeah, we've come across a number of nodule, I wouldn't say nodule fields, but
Oh, yeah.
situations. Yeah, people who are using for the west. And so more
Oh yeah. Yeah, there's like many places around the ocean basins where you can find them, but this kind of like ocean area between Hawaii and Mexico is really targeted for big industrial deep sea mining. So that's where all the studies are happening right now. There's a couple of other places with other kinds of resource interests, but Is this a test? It's an exam. No, you actually catch me on cold feet. I mean, I read the paper, or we all read the paper at some point, and I read that the nodules are supposed to or believed to form oxygen in the deep sea, which is a relatively interesting, or I would even say groundbreaking observation that was made. What I cannot tell you is about the methodology. Like, I read it a couple of months ago, and there was so much in between that I kind of shoveled that to the back of my head. But I know that a lot of people are interested into studying that further right now, especially because it's kind of, if you could confirm that, it would already be from a preservative or preservative perspective, it would already be a reason not to extract nodules, because oxygen is, as we know, very important for the whole Earth.
Yeah, I think that people accomplished while we were diving with Sebastian.
Mm-hmm.
In the area of which the project, so we did first work
Mm.
to discuss that with our collaborators.
Mm.
Experts have really significance whatsoever.
So you maybe know more about the background than me.
No, but I really the paper is everything. I just think it symbolizes how little we know.
Yeah, exactly.
We're already rushing to harvest renewable resource.
Exactly. Yeah, that plus what we regularly find and what is kind of already canon in the scientific community is that wherever you take a sample, and especially the organisms we look at, they are so small that when you, for example, right now, if you do a video transect, they're not in your mind because you don't see them with your bare eye. But they're around, and they're a very important component of the food web, for example. So yeah, for every sample that we take in the area of study that we normally work in, we find new species, undescribed species, so much that no man could describe them in their life. So that already kind of tells the story. Yeah, exactly. Myofauna, macrofauna.
Narrow bridge.
Eric, it's updated.
Update again. Crazy Estonian radio show.
I cannot, but I can give you an expert on that. Because that guy works with myofauna and I don't.
It's your turn.
It's your turn, Fritz.
You said with the,
Sorry.
you said with the modern party.
Yes. That was the one that usually goes in the journals.
Hi. Yes. Mm-hmm. I'm currently writing my master thesis about myofauna communities in the North Sea, and I also work with Amber in the company called Ines. And now I'm here to take more samples for myofauna analysis to compare our library at home.
Okay. Interesting. So let's go back to that question about the whole of myofauna in the deep sea.
Yeah, this is a tricky one for the deep sea. So for the North Sea, for example, it's clear to say that myofauna is a big part of the food web for especially juvenile fish and macrofauna in the deep sea. It's also the case, I think. It must be. But like we see here now, we don't really see that much juvenile fishes. But
First, can you tell us what the size of
myofauna is in the range from 30 micrometers to 500 micrometers, so quite small.
So that's up to 500,000
Yes.
I would say definitely smaller than almost 60.
That
Yeah, 19,000. Okay. So what that's the upper size and as Fritz is explaining, there's a very significant source for the next trophy level up. Correct?
yeah, exactly.
So what would be, let's say number,
Mhm.
what would be the
I would suggest with the furrians. Sometimes you see them when they feed, they dig a little bit in the dirt. So for example, there's also fish, I think. And also of course like smaller animals like amphipods or isopods. I would suggest that they also feed my fauna.
And what when you conduct the research, and this question also for you, also for Fritz. So you're collecting kind of the top 5 centimeters, like 7, right?
Yes.
And then what is the how do you process the samples?
So we are fixating them here on board directly with ethanol, and normally we are using also formaldehyde, but sadly we don't have that, so we use salt. And then we will just ship them back home, and at home we will then work with it. And this is a lot of steps, so we get the myofauna out of the sediment and then get a genetic approach and also morphological approach.
Okay. So after the samples are shipped back home, back to the institute, you extract the DNA from the sample,
Yeah.
and you do the full sequencing.
With one part we are doing metabarcoding, so we're using the whole sample and amplify different G markers, mostly CO1 and V1, V2. But because, for example, V1, V2 works for the most groups the best, especially for nematoda. For CO1 there's still a lag in primers for nematoda, so these often fall behind then. And then we are also doing barcoding of mostly copepods, which then also get identified as far as we can. In deep sea it's normally just the family level when you're a beginner, but we're trying to get closer to genus or species level, and then we can say we have this species and also this sequence. This would be the best outcome. And these sequences we can also put in our library for the metabarcoding, so we then find them also there in the community analysis.
Yeah, I think I'm happy with Fritz's answer. I think that was more more elaborated than I could ever say.
Yeah, Amber's working normally with macrofauna, and she's also doing barcoding of mostly isopods.
Right, there's the myofauna, feed and microfauna.
No, macrofauna. Macrofauna is the size of animals that comes above the myofauna. Yeah. For example, yeah, it's mostly made out of isopods, polychaetes, Tanaidacea, also stuff that you find in myofauna, nematoda, for example. A bunch of different things. Yeah, but the approach for macrofauna is not that sophisticated, so you you sort the sample and then you just do the barcoding. We didn't do any meta barcoding on the macrofauna samples. No, never done that.
Other than identifying species or family, you took something that was present in the sense of what other aspects do you look at in terms of what we call relations?
This is for this site, for example, so for this cruise, a difficult question because we are the first time here and just starting to getting the samples, so we can just like do baseline.
Yeah.
But for example, like Amber said, we normally work a lot of in the nodule fields,
Yeah.
and for that we have a long time series. Actually, I'm working right now with data from 2010 to 2023. And I'm analyzing the differences in the PRC flux, so the carbon flux in the ocean, and also pH values. And I'm looking if, for example, also the ENSO effect has an effect of the myofana. El Niño and El Nina. So like these climate happenings.
Oh, okay.
Yeah. Yeah, this is what we then do. And we are also looking, we are trying to see how species are distributed. So this we did now, also recently. We looked at a global data bank with our sequences and looked how far these species are distributed around the world, which is also quite interesting. For Copopoda, it was not that interesting, but Polychaeta and isopods.
So, shall I go back to because both of you have extensive experience with modules, and you mentioned maybe the aspect of oxygen, oxygen. And you know that these regions in the South Pacific are very low oxygen, but it's got very cheap oxygen regions out here. They're very extensive also. But, yeah. What do you understand about the relation between oxygen saturation levels in the water and distribution of
Very good question.
It's hard.
No, I mean, what we were trying to find out in the past was definitely always identifying environmental factors that determine the distribution of certain taxa, or even the abundance that we find in the between or among the benthic organisms in whichever size class it may be. But so far, I mean, it's always kind of tricky to even get oxygen data, because on the last cruises we only did really coring, which was deploying the multi-corer and the box corer, and we were at least for our samples not. I think we didn't even have a CTD, right? No, we didn't even have a CTD, so we don't have like live oxygen data. But yeah, for example, like just an example to show something that I think is always an interesting factor is the topography. So what we always assume is that the abundance of taxa or the abundance of organisms gets lower as deeper you get in the deep sea. But for example, what we found in one part of that study area is a very deep trough, which was about 6,200 meters, which is relatively deep in that area. And we were assuming that the abundance must have been lower, which was not the case. And I guess that was a multitude of factors. For example, we have that nutrient flow that goes through the troughs, which is probably also like the oxygen also plays a factor, like currents that go through that trough that reaches the part there. Yeah, that's basically what I can say to that. There's many environmental factors that play a role, but of course you cannot always track patterns of taxa or abundance down to that environmental factors. Yeah, that's.
Because there's simply not enough data.
Yeah, it's always trying to put the puzzle pieces together, and Fritz has been working on a script last couple of days when we didn't have to work, and he tried to understand which really were the factors of taxa abundance or that. But yeah, you never really can track it down to one or two factors. I think it's a multitude of different factors, and even if you track many of them, you will never know the full picture, at least from the data we have.
Yeah.
But it's always a good idea to deploy different gears, so you have different approaches. Yeah, but then I don't know. Our boss always says it's like sampling. I don't know, the area of, are you trying to understand the whole area of Germany, but you take like one needle somewhere in wherever part, which will not tell you anything about whole Germany. So yeah, it's always very, it's of course it's a great opportunity to study something that is so unstudied, but it gives you a multitude of questions that you have to face.
It really was.
All right. Thank you both for these fascinating deep dive into the ocean.
Thanks for those elaborated questions.
Yeah. Take your brains. I'm gonna hand over to Jimbo. Have a great rest of the I'll be back a little later.
So we specific request from others.
The largest road
Yeah, so he was actually saying around where it's like this. If we find that much, we should think about sampling something. Especially because the sizes are, I think, appropriate. Some of the smaller ones.
Do you want to chat about stuff? You want to talk about things?
No, you want to grab a road?
Yeah, I think it's good.
Bridge.
We're gonna grab her off here, but you are still getting together that waypoint.
Perfect, thank you.
Yeah, so I would suggest any of these smaller ones. Sadly, I'm not a geologist, so I really don't know what is the best thing to do, but I feel like the sizes are appropriate. And he requested to store them between the bioboxes if possible. That was what he wrote down. If you have another suggestion, then
Yeah, we can take a look and see. It looks like there's probably some space. Literally done it. You can even put a word like that. Oops. Yeah. There's one already there. That's fine. We'll figure it out. Everything there. Everything on.
Okay, so we'll chisel down. Yeah.
Choose your circle. Alright, start with on line. So whatever rock makes me the happiest.
yes,
Yeah.
you're free to choose.
It is. Like this. Anything cross ups or anything of this?
No specifications, no. So it should be fine.
Alright. It's okay. Yes. Okay. Alright. Here's slide bucket. Gauge. Honk.
Thank you.
You are welcome. Greatest rock sample. History. Everything's still in the same spot, just a little bit. Yeah, it's okay. Maybe that's somewhere. Yeah, everything's about the same. So that might be nothing. Yeah, this might seem a lot of us. That one's just a little right, so there's different position. Which is weird. But it's just. Can you change that on the software? Obviously. Photos. Not me. Not you. Cool.
Yeah, no more requests, so I think we can, if you're ready, move waypoint 11.
Cool. Yeah, it's almost great time.
Probably should have checked where you stood before. It's too late now.
Should have been. Well,
That's the console thing.
that's the part of one map. And it is better.
Only a single little special genius could only a mind who's 100% certain this takes a full
Compressor for real. Whoa. Sunny.
No, over here.
What do you want to do, man?
I don't know, what was Mike doing before?
pretending to work. Yeah, he's just checking around. Who's fun? Would you like to play some?
What do you want to do? When it's actually off, I'll fly something to it.
Yeah, buddy. We got her off. It went here. The only space was there.
Rocks.
If anything quivers, it sucks. Royally. That costs.
I did about 5. It was fun.
Oh my god. Eric is paused right now.
Travelers that always gets in the way no matter where you try.
It's better that it's shorter now, so it falls perfectly in front of it and just lift the lids on top.
Yeah. That's the point. That's not the game. It's cool.
I like that she just has to play with it
That's amazing.
Lord. That's it.
Okay, so you stop us now.
Yeah. Yeah. I'm gonna mount belts out again. Get her out. 75. Reasonably happy. But whatever works.
Perfecto. Yeah, visual.
Yeah. Have fun. Don't try. Dude, just do it. Just have fun.
So yeah, we basically just went from one waypoint to another. Not much something requests, at least not for now.
Continue to see the same.
Yeah. Okay. Thank you.
Yeah, so this is the edge of your river. So you're 20%, this is all your walls. Or what's on there. What number is the answer? 7. I think the 6 actually leveled up, right? There is a few. It's labeled correctly, but the porch isn't. The porch is flat. Okay. The bio boxes is on the opposite edge. Your index is right. Your starboard round, foreground is right. Your index is right. Your mistakes, I don't know if that's.
In the skin was next to the bottom starter.
Yeah.
Number 6.
Yeah.
I can't remember which index is. Index is 4.
Index is starboard on the starboard, yeah.
Very happy now.
No, less than left, you know, oh yeah. Did you turn it off from cruise or from lock?
Yeah.
Because sometimes press the lock, you might still have birds, and cruise like only does your axials. but when you put lock in, it does actual adverts, but only the cruise light will turn on in this one. The lock light doesn't
Okay.
turn on. That's probably what got you there. It's too steep going down, just a lot of them. They're trying to like that. They're trying to keep all this slope over. Looks like it's deeper into your core, higher your stronger dimension.
And there's very high sedimentation here. Everything is covered. Updated waypoint bridge.
Updating it.
Can we move on to the next one?
Yeah.
high currents, or is it from the ROV?
It's from the ROVs, because we're coming down a steep slope,
Yeah, yeah,
and obviously the thruster wash,
yeah.
as we're coming down, the thruster wash is higher than what the sediment is, so it just gets caught and stirred.
Yeah.
It's a problem when you try and come down steep slopes. It's alright if you're coming up. Change the waypoint a little bit, control.
Thank you.
Are you guys going to have the like behind your parent?
What's that?
Are you guys not like to have the launch point of your directly behind your? So instead of it being offset, yeah, instead of it being offset, why don't you put the vessel on the line behind us?
Well, the reason of just now that we're staying out of the way enough. That's also that this is a bit lower than what this is. So the idea is if we get more delta and stuff that's needed to be resting on the hill, it's going to be like down the hill.
Yeah, but not.
Plus we're going to come this way anyway, so it's going to, you're going to come up here and then you're going to be leading forward the vessel back and do this way anyway.
There's an offset, right? Like the waypoint 13 here is the waypoint 13, already one further down. Yeah, it is.
Yeah, just like it.
Yeah. No, alright. I was just confused. That is a very big sea cucumber. Can you zoom in on that?
It's
I
right
think,
there.
yeah. Please. Sleeping octopus, yes. If you want, make it closer. It's probably sleeping.
This is camera working in.
No, with our camera angles here and stuff over there. You come around and match the hill. I mean, so it doesn't face nothing like that. So, too high. You turn it off. It looks like it's sloping up a little bit there.
No idea, actually. No idea. I was just assuming because it's kind of curled up. That's what I do when I'm in bed.
Yeah.
Kind of the same position. So I probably overinterpreted its behavior.
But it's cute.
Yeah, nice. Shiny. Almost looks bioluminescent.
Funny light.
Here's Pedro.
No, yeah. I'm just thinking like if it's not moving, there's not much for us there.
I'm only putting on this light because I know Alex Paris will be watching.
Yeah, he's
there,
watching. I was with him now.
And he hates this blue
Oh,
light.
really?
And I'll always put it on.
But what is this blue light?
It's just the inner cathodics.
So isn't it different Kelvin?
It just looks a bit purple.
Okay.
But to be honest, I think it's quite good for like mid-water gelatinous things, but not so good for anything else. But I know Alex Paris hates it, so I just put it on.
He's there
for
watching. I was
just
with
for
him.
him.
You're trying to torment your minions.
Oh, you see changing color?
Yeah, I was being fucking nice with that. So we got is going through now. So
There's quite some current. You see like the top side there.
Just wood forced it ahead a little bit.
Yeah, I would suspect that waypoint 14 will have some because of the downslide. We'll see. Where is 15 though? Ah. Okay, so 16 is what is between 13 and 15?
14.
And that is over there. Okay. Well. Okay.
So 15 and 16 is close by.
Okay.
You're on the left.
Yeah.
Red tail.
So if you get zoom in, then that's awesome. Chile's on that.
Much appreciated. Thank you. Okay. So, da ich jetzt die Möglichkeit habe, auch auf meiner Muttersprache zu sprechen, dachte ich, ich stelle nochmal das Senckenberg vor, von dem wir hierher gefahren oder geflogen sind. Also wir sind 3 Wissenschaftler, die vom Senckenberg am Meer kommen in Wilhelmshaven, 3 Biologen und fahren auf die Fahrt, um die Meiofauna der tatsächlich alles ein bisschen schwierig auf Englisch zu übersetzen, aber die Meiofauna der Chile Margin zu erforschen, die tatsächlich relativ unerforscht ist. Wir haben zwar einen Kollegen, der da auf dem Gebiet viel gemacht hat, da der Kollege auch Verbindungen zu Chile hat. Aber wir kommen natürlich nach Hause mit neuen Proben und schauen uns dann an, was wir so Schönes gefunden haben.
Update your waypoint just to keep moving the bridge.
Und ja, an der Stelle gehen die Grüße raus an Gina Dambrowski, an Pedro Martinez, an Antonia Kaiser, an Patricia Kaiser. Habe ich wen vergessen? Nee. Und an alle vom Senckenberg. Das war's. Awesome. Big sea cucumber. Too fast.
Update your waypoint again, bridge.
Update.
Ja. Let's see what awaits us at the end of the slope. Some geologists were suggesting it's fault lines, so I don't know what we're gonna find. Especially the waypoint 16 alternative is supposed to be a deeper fault line, probably covered in sediments.
updated waypoint village.
Okay, thank you.
You can speed up the speed for you as well.
Alright, thank you.
Staring into the abyss. So what are we seeing here, Ansan? Is this outcrop that is kind of fragmented? Someone was mentioning earlier that the roundish rocks are still remnants of the outcrop, and everything that is more or less fragmented is kind of like disintegrating.
Right, the roundish features, those are pillow basalts. So that's where a direct interface occurred between the water and the lava.
Mm-hmm.
So
that makes the particular shape.
yeah, that's why it's round, because the thermodynamic properties of the lava are such that when it touches the water, it cools down, and the bulb wants to expand, but it will only expand so much before the shell cools and creates like a pressure that causes the internal lava source to go elsewhere, and elsewhere might just be right 1 meter away. And that just happens. You'll see pillow lavas grow. Like one will form, it will harden, no longer be growable, and then you'll see another one right next to it form. And sometimes the insides of them tend to be a little bit hollow. If you have a situation where pillow basalts form, once the outer shell forms, the interior can still be liquid, and lava tends to go downhill. So the lava that makes up the interior of the pillow basalt will tend to flow somewhere else. So you tend to get these pillow basalts that have relatively thick shells, and you might have like a very the interior might have a void space, and that's because the lava drained elsewhere downhill. A lot of this is broken up. A lot of this that you see is pillow basalts from uphill that that weathered away and broke apart from, like, they became de-anchored from their outcrop, and then they fell.
Okay.
part of the fracturing is from weathering, but the mechanism that forms pill basalts, it introduces a lot of fractures and joints just in the first place. So
okay. That's why you also see these cuts. Like sometimes they look like they're right cut off or something.
Right. There's like some pill basalts. There's a characteristic way they form. They might grow, like they might grow frontally, like I guess you could think of it as like a growing worm basalt, or like an expanding sausage balloon basalt. Like, but when it does that, you get fractures that form, and those fractures are the location for water to be introduced into the interior of the rock, and then chemically weather it and cause that to eventually get weak and fall down off the side of the outcrop.
And about the age of like formation or the age of those rocks, you can only say something after you sampled them, I guess.
No, you can make assumptions about the age. Like for this case, it's pretty fun to calculate the age of this one. So the central axis of the spreading center is about 1.4 kilometers away or so, give or take a little bit, but that's 1.4 kilometers. That's 1,400 meters. 1,400,000 millimeters. And the spreading center grows at a rate of about 35 millimeters per year on each side. So take 1,400,000 millimeters divided by 35, and then you get 40,000. And that's based on a couple of assumptions, like the spreading rate isn't always 35,000 years. And it's the axis might not be exactly 1.4 kilometers from here, but that's like an upper limit for what the age could be. Like you couldn't be any older than 40,000 years old. It's probably quite a bit younger. You could date it. You could take a sample and then study the isotopes. Potassium argon is a good one. Carbon dating, it might be the right age for carbon dating. I'm not in the know about if carbon would be the best isotope to use, because when this was formed, it was mineral, and carbon dating requires carbon-14 from the atmosphere. So you'd have to somehow use like life that immediately interacted with the rock.
Yeah, I understand. Might be an error on bias.
Yeah. And there is like a bias down here too for carbon dating. It takes a little bit longer for atmospheric. We produced carbon-14 to come down this deep, so you'd have to make a correction for carbon dating down at the bottom of the ocean than in the atmosphere, because there's that time lag that it takes for carbon-14 to both diffuse and to
we can reduce the
affect them.
speed slightly just now.
You swoop away all the sea cucumbers. bunch of corals, crab, some anemones.
I think they got the most wonderful one earlier on.
That is a sea cucumber.
Rock.
Very elegant. Seems to be accompanied by something else. Might be a shrimp or a meseed. True. Oui. Uh-huh. Nice one.
Shrimp?
Yeah, or isn't Fritz meseed and shrimp, is it the same thing? Musida? Are musida shrimps? Yeah. So yeah, it's a shrimp in any case. I think it's a musida. Nice. So what we see is a flying sea cucumber, also known as holothurian, accompanied by a small shrimp.
Cowboy shrimp.
Company shrimp, yeah. This actually makes me think that I'm glad that humans are not transparent. You know, if you see that, it's like intruding their privacy.
Yeah.
Alright, don't.
We see, I guess, what is an amphipod in the water column. Yeah, that's an amphipod. I guess it's impossible to sample that, no? Let's not try.
It's not possible.
You want it?
Nah, don't worry about it.
Catching in the camera lens.
Yes, exactly. It seems to have the same path as we, though. There it is. Ooh, that was a copper pot, no?
updated waypoint bridge.
Update.
That's also 13 now.
Can you remind me again where 14 was? It was super far off, no?
Yeah, very far away.
Yeah.
Like 3,000 meters away.
I think I'm not.
It's super far. Can you zoom out a bit to show me?
Yeah, it's
Like
like.
so.
I'll give you
Ah, you see them up there? Ansel? You know-
That looks like an error.
An arrow, right?
2.5 kilometers.
Yeah, because I wouldn't know who requested that one, so I would skip that one.
That is completely
Yeah. No, I'll skip that one and go directly to the next one.
How about move it?
So we'll go have a walk in. Andreas might have been interested, but I think it was under discussion just to
Yeah.
take over this area.
What's up, Luke? Keep it there.
Thank you.
Unless they wanted to give this famous transect
Yeah, but
unless
but then I would suggest that they would have put waypoints in between. You know,
yeah,
like
exactly. I agree.
that one looks like an outlier.
So I will update the waypoint bridge.
Slightly.
Update here.
No, definitely. I mean, Gonzalo is here. Huh? Really?
I've moved it on and off.
No, I still am supposed to move as a tech here. Because
The
over
other
there,
side,
it was
over here.
really far. No, it was an error, right? Yeah, okay. We keep this circle.
Okay.
Much better.
Thanks for being
Outside.
flexible.
You do whatever you guys want.
I did go way over there. Never mind.
Good that we rechecked, otherwise it would have been, what are we doing here? No, I think the goal was to see the volcano, to explore the volcano, not some random other place. Ah, what is that? Is it a conch jelly?
Yes.
Yeah.
Yes.
A what jelly?
Conch jelly? So
A comb jelly?
yeah,
Come jelly.
Comb jelly?
like the thing you brush your hair with.
Oh, comb jelly.
Yeah. Ah, damn it. Awesome. Ooh. So cool.
Okay. The further sea coaches.
Nice one.
Yeah, prefer that one not being yeah.
That's all.
Yeah, it's fine. Good.
Date waypoint bridge.
Update, thank you.
out of waypoints.
Oh,
I think that one is the only updated thing. There's one missing because there was an outlier, number 14.
14 was like way over.
Yeah, it's like way out. That was-
Okay, so we're going in this.
Yeah. We're like in the plane right now,
Yeah, yeah, yeah.
or more or less the plane, and we're approaching, I think what it is, a fault line,
Yeah.
like the darkish spot, and then we're going upslope again.
How are you doing? What's your port situation?
The bio boxes are, there's space, but I'm suspecting that there will be a couple of people tomorrow during the day who want to use them. So since there's no requests, and we personally don't have any requests.
Wait, these are coral clippers.
These are coral clippers.
You have one coral clipper left?
Yeah, but that's Anna. And these are empty. This is empty. This is reserved for the sponges.
2 spots in the suction.
Sure. Exactly. And then there's a lot, and all the push cores, but that's what I know of is gonna happen tomorrow at last, like the last one of the last sampling things. And then there's a lot of rocks on the rock, randomly distributed on the rock for Andres.
Press the cruise button instead of lock. That'll just do your. That'll just do your. Access.
I got you. Well, I'll try this time. It turns out more about.
You lock, but if you do it from this one, it'll just do your action transfers. All options stay on. But I think the lock button does cruise and.
Yeah, well, when I pressed lock this, I had all on it turned out all.
Aye. Because that one does all your thrusters, and cruise on its own, it only does your. It doesn't affect your parts. It's fun on left.
Otherwise, we can't survive.
Well,
They won't fly.
Waypoint Bridge.
Update.
So for everybody who just joined in YouTube or on whatever platform, we are at the Triple Junction site exploring a geologically spoken relatively young volcano with what I know now 45,000-year-old pillow lava outcrops. We're on the outer rim of that young volcano, We have kind of encircled the volcano in the last couple of hours. Now we're coming back more to the south, and yeah, going a bit upslope in a couple of, probably in an hour or so, and then see what is. We've already been at the highest point, if I can remember correctly, but we're gonna go back inside over the rim and see what is waiting there in terms of geology and also, of course, biology. That, I guess, is a crinoid and 2 anemones and a two corals, a couple of shrimps. Can you zoom in on that one?
Yeah.
No idea what it is. Like the yellowish thing. Could that be a bone or something? I don't know. No. So I would say the animals are definitely feeding from it, whatever it is or was. Oh, you can continue. Don't worry. No, we don't want it. Yes, after 15.
Can we stop and get to the
Hmm?
I'll stop in the vessel and move just now.
Oh, it's nice.
Okay. Yes, HD probe, and does it need to be?
So you just take a probe and stick it in, see what it gives.
Into the sediment.
Yep.
Right.
And would it work just to leave it in the claw? If we're gonna do this a few more times. Would that work? Just to claw it? Can it just be clawed? Just so like we
Yeah,
can-
yeah, yeah. I will
okay.
stick it. I will. So use the neck, yeah.
It's straight or deeper, right? Once you grab this angle.
Does it need to be locked here? Does it need to be locked here?
Yeah, find somewhere. Yeah, just write down waypoint 14.
Time and depth and stuff.
Yeah.
Tighten it before you run out from that. You can't doesn't really cool and concentrate. Okay, before you stick it in, 3 and 1, 32. Okay, stick in.
Okay, what was the background?
132, and it's almost 132 still.
Where's the gotcha. Okay. Alright, withdraw and move on.
Keep it in the arm.
Yeah, keep it in the arm.
Put over the right now. With the mini color, facing color. Put it over the suction. So it's already color facing.
Just want to stretch this table too much and then you really won't see where the end is if we're digging this in. using this again soon, I think.
Yes, I'd like to use it a couple times as we approach the volcano. Probably before we collect any samples, so I think it's worth it to leave it in the claw. If it works.
Yeah, but you can continue that move.
Are we ready to continue move?
Yeah, you can continue. Thank you.
Thank you.
Zoom out on that one just so I see what our distance is from that.
chunky sea star.
Can we stop at that yellow dot up there and just do a temperature measurement again?
The one that is approaching? Yes, okay. So we would like to stop at the approaching yellow point and take another temperature probe, HD.
Updated waypoint bridge.
Update.
Here.
Yeah, please. No, Emily.
Stick it in a little bit. How deep can you go?
Does you want to push it?
Yeah, just
Same 132.
okay. All right, thank you.
Okay.
Thank you. Okay, you can continue to the next waypoint when you're ready.
Roger.
Yes. First, this one's. So we're slowly starting to ascend on the slope of the volcanic structure and off to the next waypoint.
Updated waypoint bridge.
Update.
Ah, nice one. finally something. Rocks and corals. The green worm thing. It's whatever it is.
Spoonworm.
Spoonworm. Thanks. So yeah, Anselm would like to have another heat probe at the next waypoint, but I can give you further instructions when I'm there.
Okay.
Oh, there's another octopus, if you have the time. I think it's the first one today we see in that color. The other ones were kind of whitish blue. That one is wide awake compared to the other one. The eyes are big. Nice one. You think that is a kind of a wooden structure, or is something else? It's very particular.
This is amazing. Has anyone been Keep this camera seat. It's gonna be pretty high by now.
Come on, just keep moving. Just move twice. Neither of us are touching it.
Later, dude.
Wir den Stock haben. Auf den Upgrade. Ist das ein Stock?
Ja, du hast recht. Ja, das ist awesome. What? I think it took the piece that was on the seafloor.
Maybe. Stretch its arms.
Nice one, thank you.
It's got a branch. It's like its arms, and it's just like that.
That's for the
There is something. Right? Did you see it? There is something. Did you see it?
The temperature probe is in the power arm right now. Off to the side.
Ah, what is that?
Yeah, look at it. It's here now.
Oh.
We'll stop for this guy first.
Here. Now it's here. Getting angry.
also the handles like around as well. I'll have to do some of that handle and probably try and see more play on the cable because it doesn't look like there's very much because I was using it like right at the front of the porch and you can barely even see it going in and you have enough trouble with the back end.
So what we could point to switch, no?
I don't understand if she's having a dinner. That's why things
At first to me it looked like a wooden stick or something, but now with that thing coming out of there, no idea. So Anson, I'm gonna switch, okay? It's your shift now, right? We have no requests.
You want to do your temp probe here while we're sat? It's pretty much the waypoint.
Sure, yeah, that's good.
See you guys.
The temperature on this display?
Yeah.
Play music and stuff. It wasn't working when I got there.
How deep can you go in? Can you go in deeper?
I don't want to go too deep here because it seems like there's like
All right.
schools by.
Okay. Well, let's go somewhere where we can stick it in then. Okay.
Max probe.
Max probe.
No change.
Where's the temperature displayed at?
It is
Okay.
right there.
Okay, thank you. All done.
Probe again. was modified less than the compact.
Thank you.
Oh well. Yeah, what do you need? I just need to see, 'cause I'm just gonna stow it on the inside, but I don't want to put it super far out. After some snagging. But I can't see.
What if we do this?
I think I'm still within that third. You have to deal with it. Big problems, that's right.
Yeah, I mean, I can't really
Okay.
Continuing on up line. Coming up.
One day, get a lot of delta out.
Where's the ISO at 12? Put it up so you can see. I see. That's an idea. Here, there's a reason.
Do you guys have, how many just rules of maps? I think so.
continue on. Okay, this is Schmidt Ocean Institute, revealing the experience of ROV Sebastian, the robotic remotely operated vehicle Sebastian on Falcor 2. I'm Anson Entriasian from Oregon State University and NOAA, and we're here to investigate the situation that exists near the Chile Triple Junction. This is the first time that ROVs have been used to get visuals in this area. This here is the flank of a volcano called Capuche Volcano. It has a meaningful name. It means the last descendant, and it is could be up to 40,000 years old, but maybe much younger. It's hard to date lava around this time. You can't just use potassium argon dating or uranium dating, because those systems are more suited for much older time scales in terms of millions of years. So lately people have been very creative in finding new ways to use isotopes to date younger volcanic rocks. So this could be anywhere up to 40,000 years, but geologically that's young. Right here what you're seeing is the flanks of the volcano covered with pelagic sediment. And this is a mixture of some debris that was deposited here, sediment from the continent, from the South America plate, especially the subduction zone. And also it's an accumulation of organic matter. We're exploring to see what life exists here and to characterize the environment of the Chile Triple Junction. This is where three tectonic plates come together, and it's the only place in the world where a spreading center, which is also known as a divergent plate boundary, it's the only place in the world where one of those is subducting underneath a continent. The divergent plate boundary is a place where a new oceanic crust is forming. The crust is about 6 kilometers thick after it forms. And the two halves of the spreading center diverge away from each other for one another at a rate of about 70 millimeters per year here. So about the growth rate of a fingernail. Those two plates that are produced on either side of the what's called the axial valley of the spreading center are the Nazca plate to the west, which is subducting underneath the South America plate. Sorry, the Nazca plate to the east, and then to the west, there's the Antarctic plate. Even though we can say they're two different plates, they have similar chemistry, they have a similar history, because the two halves of the plates that are spreading apart from one another were formed in the same location by a axial magma chamber, and they were both given the same chemistry at the time of their genesis. So it's like human twins, identical twins. So when they're born, they have the same genetic makeup and the same size and chemistry. But as they get older, they might move away into different cribs, or then they might move away into different bedrooms, different schools, and different places in the world as time goes on. So it's like that with the divergent plate boundary. The two sides of the plate are very similar during Genesis, then as time goes on, they develop different histories. And in this case, the Nazca plate is developing the history of subducting underneath the South America plate. And those two sides of the divergent plate boundary, they're chemically similar. They're superficially basalt, and as you go down deeper is gabbro. Rocks that are typically more magnesium bearing and iron bearing than continental rocks. And when you look on a planetary map and you see the structure of the seafloor, you can see similar faults, similar fractures on either side of a divergent plate boundary. But these two plates, where they join, they're subducting underneath something that's quite different. The continental plate is chemically and structurally very different from an oceanic plate. So you're getting two similar plates that are like human twins subducting underneath another plate that is like a different animal. It has a different chemistry, has a different buoyancy, has different structural strength. The South America plate has a different thickness. It's quite a bit thicker than several times thicker than the oceanic crust. The Nazca plate is subducting beneath it. There are other places where you get three plates coming together. In the central Indian Ridge in the Indian Ocean, you get three oceanic plates come together at one location. And there's other triple junctions in the world too. sometimes two of them will persist and produce new crust, and then the third axial valley might die over time. But this is the only place where you get two oceanic plates subducting underneath the continent. And this volcano here is a consequence of that interaction. Or it's becoming a consequence. It hasn't fully accreted to the South America plate yet, if it will. But after its formation next to the axial valley, it's been faulting, and it's been this series of small volcanoes that are each only a couple kilometers across. They're becoming faulted and moved and shifted. And if we're around for several more million years, it'd be interesting to see if they get subducted beneath the South America plate, or if they just get accreted to it. Accreted to it so that it becomes part of the plate, and in long time it could make up a part of its structure that we could stand on. Yeah, I think that's right. If there was three plates forming at the same time, it might be called a triplet. That'd be a good analogy for the Central Indian Ridge, because they each have a similar chemistry and genetic composition, structurally. They're both formed in the same place at the same time with the same materials. But here, you're getting two similar plates subducting underneath something that's quite different. The continental plate, which is known as the South America plate, is very buoyant. The reason why the oceanic crust is subducting underneath the South America plate is because it's denser, it's heavier. The South America plate, it floats. That's why it's higher.
Hey, I'm just making sure that I answered in the affirmative before the vote.
You did. And the price is high. We're on good.
So right now we're transiting to the edifice of the volcano. This is called Capuche volcano. And we're just seeing the flanks covered with pelagic sediment. Eventually, we'll probably see some outcropping rocks, which up to this point in the expedition they've been a host of interesting communities of life. One of the goals of this expedition is to look for locations of focused flow of fluid, either from hydrothermal vents, which have sourced heat from the tectonic region, from the thermodynamic properties of the tectonic region. We're also looking for seeps that could be fluid seeps that would be discharging fluid driven by other properties, such as thermal-driven buoyancy. And it turns out that structures that are edifices, if they have a high porosity and high permeability, like pillow basalts. Pillow basalts are an example of a rock that's, it in itself is not a very permeable rock, but if you take these pillow basalts and cluster them together, then the pathways in between each pillow effectively gives you a high permeability material, like an open pore sponge. And so we're looking for potential sites where fluid could be discharging as a result of heating up in one part of the volcanic edifice and then being discharged somewhere higher.
Anything
The waypoint. We still have the temperature probe holstered.
It's out.
All right. Just go on to 17.
17? Yeah.
All right, one of the questions is the East Pacific Rise overall moving away from South America Chile Trench? Or is the subduction here faster than the spreading? Well, right here, the subduction in here is faster than the spreading. The axial valley itself is being subducted, so the Chile, the East Pacific Rise is a little bit different than the tectonic setting in North America where the Juan de Fuca plate is. Up there, there's a spreading center as well, and it's producing the Juan de Fuca plate and the Explorer plate. And those plates are being forced underneath the North America plate, underneath Northern California, Oregon, and Washington, but the axial valley itself is not being forced eastward. The axial valley itself is moving to the northwest. But this situation is different here. The entire axial valley and both plates, the Antarctic plate and the Nazca plate, are being slowly pushed below South America. So right now we're still looking at pelagic sediment. It's like this all across the region, with some outcropping of pillow basalts around this volcano. Sometimes we see little pits and holes in the seafloor, and I wonder what moved away. We see there's a star and some sea cucumbers. That's what the clear creatures that we just passed, those are lovingly known as sea pigs, but they're a type of sea cucumber. Those have been around for about 450 million years, but unlike us, they haven't diversified much. One of the questions I have is, why is it that some creatures diversify and change and evolve, and some just stick with the code? Why is it that some of those sea cucumbers have just kept their genetic code the whole time, ever since 450 million years ago? So the little balls that you see, they look like sort of, I don't know what you'd say, like circular spherical sponges. Those are called xenophylloporia. Xenophylloporia, 7 syllables. And those are colonies of single-celled organisms, foraminifera. And they're very diverse. Foraminifera are used in a geologic context as dating tools because they have diversified and evolved across the millions of years. And it's known that certain types of foraminiferas existed at certain times in Earth history. And so we can use those foraminifera to date the age of rocks, sedimentary rocks. But there's no sedimentary rocks here except for this pelagic sediment, which one might say is a precursor to a sedimentary rock. So a sedimentary rock in forming. It hasn't been indurated yet. It hasn't been formed into a rock. Here's a piece of basalt, an anemone. These pieces of basalt have, with no doubt, come from above, from higher ground, probably sourced from pillow basalts. And if you look inside some of the rocks, you can see void spaces. And that's because the pillow basalts form as lava approaches the seafloor, and once it gets exposed to seawater, the exterior of the lava chills and cools, and the liquid interior has to find a new path of least resistance. So it goes to the side. And when it does that, you get a series of pillow-like structures that aren't as structurally integrated into one another as like a solid granite structure or a lava flow that cooled. And there's several different mechanisms which can cause them to fall down the slope. And it might look like Thor's hammer came and crushed up the rock, but a lot of these broken up fragments are from pillow basalts that used to be round, and as they cooled, fractures formed, internal fractures that over time gave way and allowed the rock to be chemically separated. Like inside the fractured, water and organic material and chemicals would tend to deepen the fracture and then separate the rock from itself. Then you get a downward falling of debris. It's very gradual. Let's do another temperature measurement at 17.
Roger that. 17. Shrimp.
Little red shrimp. So these are, I think, corals. To the left, octocorals. If we can zoom in, what's that? Is that an octopus? Huh. Yeah, I don't know what to say about that. Looks non-responsive. C3-4. Yeah, it wouldn't be right.
All right.
Here we see another octopus. Does anybody know the species or the name of this one? There's a brittle star in the foreground and then the octopus in the center. Yep. It's pretty cute. It's an interesting structure right in front of the octopus. I don't know what that is. Yeah. Yeah, let's keep going. So this type of video is a good opportunity for anyone to practice their drawing skills.
endless number of benthic life to draw sketches of anemone, shrimp, coral, crinoid. Crinoid's the yellow one. I've noticed during this dive that where there's rocks, there seems to be more opportunities for fauna to anchor to. And so in the more plain-like pelagic settings, we might see sea cucumbers, maybe some echinoderms. But then when we get to rocks, we see more corals because they can provide an anchoring mechanism. The ocean floor, it's predominantly unexplored. We're exploring it now and we're producing data of what it's like to bring back to the surface. But even then, it's always going to be effectively an alien environment for us that live on land, because the only way we can interact with these creatures is if we bring them up to the surface, and then they're in a different state. At this depth, we don't thrive. This isn't currently a place for us. And so this is a very otherworldly environment, and it seems like it will be for a long time. Get a, oh, I already said get a temperature at 17, right? Another sea star. That one has a unique morphology compared to what we've been seeing. What they call a rat-tailed fish. This area looks cold and quiet now, but just the mere existence of these rocks indicate that something, I wouldn't say violent, but something extreme happened in the past. Extreme insofar as rock of great temperature came up and exposed itself to the seafloor. Why then and why not now? That's just because the dynamics of local sectors of the Earth change. Sometimes thermal energy is exhausted.
Right.
We're going to pause in a moment to do a quick temperature measurement, so you don't need you to come fast on break. Just a second.
Okay, I'll just come down to the bed soon.
Thank you.
Cheers.
All right.
What do we got with the? Okay, that's typical. Would you know if you hit something hard? Okay. All right. Same as before. Thank you. There's a very showy octocoral anchored to a rock. So, in the hydrothermal setting, where you have a warm water circulation, it heats up the subsurface. There are probes that we can use to go deep into the seafloor, like 1 meter, 3 meters, to measure the temperature. And the temperature gradient indicates if there's a thermal source below the seafloor. And so we have a very short probe. It'll only give us an indication in an extreme situation. But there's a chance that that as we approach the volcano, we might see a subseafloor thermal image. And if nothing else, it indicates that this area could be thermally static. Everywhere in the Earth, as you go deeper, it gets warmer. On the ocean crust, on average, it's about 60. Let me think. right, so according to a back of the envelope calculation, in the background oceanic crust, which has a heat flow of 60 milliwatts per square meter, you might expect the temperature to increase by about 0.02 degrees per meter. In a region of high heat flow where there's hot water beneath the seafloor, it'd be greater than that. And you can potentially measure that with a small probe. That is. Across all of our surveys in the Chile Triple Junction so far, we've seen these what are called brittle stars across the past week or so. Not too much comes down here, except for the locals. This is the first time that we've sent an ROV down here. So when you see these little structures on the seafloor, each one of them has a story. Each one of those lumps, or a pit, is there for a reason. Something made it. So these pits here, I'm not sure what, but seems plausible that it would be nests or something. So once again, this is Schmidt Ocean Institute. The remotely operated vehicle that we call Sebastian is exploring the seafloor at Capuche Volcano at what's known as the Chile Triple Junction, which is near where the convergence of, where the joining of two tectonic plates, two oceanic plates, is subducting underneath a third continental plate, which is the South America plate. I'm Anson Entriasian, here from Oregon State University and NOAA. And in addition to exploring visually what we've done in the past at another site several days ago, was we used a very high resolution sonar mapping instrument. It's called the M3, and so using that we could fly over the water at about 25 meters altitude and then get a detailed map of the seafloor. The downside of that is that you don't actually get to see the seafloor, so you miss out on all that data. It's basically a different, it's a very different type of measurement. So you're studying the seafloor using acoustic waves through water, and you're ignoring photons completely. But down here, it's the other way around. We're not really paying attention to acoustic waves through water. We're paying attention to photons that we emit from our floodlights and bounce back to our cameras. So it's very different, and it gives us a different data set. Photons being much smaller allow us to study materials in much greater detail. You can become more aware of the fineness of their structure, and we get a sense of what's called color. And the photons that we see when we say something's purple, like that. Is that also holothuria?
Yes.
All right, when we see something pink and purple like this holothuria, a type of sea cucumber, those are photons that are pink or purple, that it is reflecting back. And then all the other photons are absorbed, the blue and yellow. So in a certain sense, when you see the color of something, like that holothuria that's red, you're seeing that's the color that it's not. That's the color that it gave back to us. Colors that it absorbed, blue and yellow and green. Those actually become part of the organism. Zoom out on the map so I can just get a sense of what the future looks like. Oh, it goes up to 18. Still need to do fish quarters. Is the fish quarters in here?
They got checked.
That's the last thing, like forming the summit. Okay, we're going to the caldera now, but then once we go to the caldera, do they want to collect all these fish cores? Or how many? We have 16.
16?
Yeah, so should we take them all there? Or?
No. In here they don't say, so 16. 16 push. No,
Oh,
they just,
16, so is
they
that-
don't say the number. I know that 4 are Marlow, Erin plus air, so 4. It's October.
Oh, that one? Oh, wait, no.
No, Seapen. No,
So not Seapen. Is
No,
that
it's a Seapen. It's the one that we collect if you...
Is it? Okay.
It's October, but Seapen. It's a real umbrella. This one.
So each one of those flowers have 8?
Yeah.
7, and each one of those has 7.
Yeah.
So it rules out it being a hockey soil.
But the sea
Could you attempt to pin up?
is. This one. Sí. Es ortopedia.
That's all I have.
No, but some of them, like you see that one is broken, is volcanics. That is a sea.
Okay.
This has a small foot here, like this.
Well, that one's got 8.
And if you count
If
this
they're
one,
off.
for example,
That's what that was.
they have 8. But this one you see that is short.
Yeah, okay. I see.
So, sí, tenemos una sí, esto como sí. Sí. Sí, estoy
Have the anthropoid traps been deployed? Have the anthropoid traps been deployed?
yes, they told me that they have, but I don't know if they have the point. Maybe they wrote here.
I'm not sure.
I don't think we brought any of the pond traps down.
Oh, they're not on the RV?
I don't believe so.
You could fill it up. There's no problem. There's no.
But it's the last things that we want to do. So
That's
tomorrow
understandable.
morning, Patricia will do the push call.
Okay.
Patricia will
Okay.
You guys want to continue?
Yeah. Can you zoom out a little bit again? I just want to see where we've been. A little more, please. Okay. Let's go to the next site and take another temperature.
All right.
Do we need more requests for sponges?
Yeah.
We have room for more sponges.
The Vanessa in this one was really close to the end of the.
Oh yeah, so
Because she
so that they don't
make
age.
incubation. That's why we are waiting.
All right, so we have room for a sponge.
Yeah, and here we can put two sponges of the same species, for example.
Okay.
And then we have room for here for any other organisms, and then these two we can, yeah,
Yeah.
in case one section and one we keep, in case we found that this probably gets swim out here.
This one has a filter in it, so what would the filter be appropriate for? This one gets filtered.
Yeah, but I think we need to use it. And then push cloth. We find this sponge and we close it.
Oh, sorry. When we put the sponge?
We treat the skin. because she needs the water from the escape.
Okay, that'll be later on. That'll be.
Yeah.
So it looks like we can collect some rock samples
Yeah.
and
And then
a few more
when I
weeks.
found it in the last color, because here we have the
And also at the very end.
no, when I found it.
Okay. Just say we're doing it.
I can believe it now. I see it.
So once again, this is Schmidt Ocean Institute. I'm Anson from Oregon State University in NOAA. We're studying the seafloor here, but we're also carrying with us a battery of instruments to study the water that we're going through right now. At this moment, we're collecting data on the salinity of the water. We're collecting data on the water's temperature, and if you are curious, right now it's 1.8 degrees Celsius, so it's pretty cold. At the seafloor, it's usually somewhere between that and 4 degrees Celsius. It's common to have that bottom water temperature. We also measure the oxidation reduction potential right now. So oxidation reduction potential, it's a mouthful. So basically what it is, it's the measurement of the tendency for chemicals to exist in the water that want to react. And if an atom that's all by itself, if it has its full electron shell, like an iron, for example, it's considered to be not reacted. It's considered to be reduced. And when it interacts with other atoms and life, those interactions pull away the 2 valency electrons that it has that it doesn't really care that much about. And then that's considered an oxidized state. So we're sensing to see if there's any chemicals in the water, or we're putting sensors in there to detect the capacity for the chemicals to still react. And at this point, it's not a highly reactive setting. The tool, the oxidation reduction potential meter, it's used predominantly for hunting for hydrothermal vents, because when these vents discharge fluid, oftentimes, not all, but oftentimes, there's chemicals that are still in their not fully reacted state. So you get hydrogen 2, which wants to interact with life. When hydrogen 2 comes up to the seafloor, it has a half-life of hours or days. And then there's also methane. Methane lasts a little bit longer, maybe on the order of weeks, but it eventually reacts. And also metals. When they get to the sea, they react. And so we use these, we search for these chemicals, hydrogen, methane, and others as a way of finding hydrothermal plumes. And at this time, I'm not seeing any. Very occasionally there will be an ORP spike, maybe for just one data point, but I don't consider it very meaningful. Also, what we're measuring is turbidity. Turbidity is the property of how turbid the water is. The term turbidite is a is a term for when there's a storm on a continent, on the coastal setting, and then the storm washes water into a river, and then the river discharges into the ocean, and that event could cause a turbidite to form, which is like a layer of sediments. Some of them could be thin, some of them could be thick, a meter. But this sensor measures turbidity, which is how many particles, or not how many, but how reflective the material is in the water. There's different ways to measure it. You can shine a light through the water and see how much light gets through and comes out on a sensor on the other side. That measures the transmissivity. And then there's a sensor that shines light at the water and that measures how much bounces back. That's called a backscattering sensor. But both of them are used to measure turbidity, which is how much particulates are floating around in the water. And that's important because the particles in the water contribute to the ecosystem. They transport nutrients from one place to another. They contribute to the sedimentation rate. All right, what was the... Okay. All right. Let's bounce.
Disengage probe.
How's that waypoint 18? Let's see what else we have. So we measured temperature, salinity, water pressure, which is effectively depth, turbidity, which is what the particulate content of the water is, oxidation reduction potential. And also we have a sensor called the SAGE sensor. It measures methane, 1 carbon and 4 hydrogens. Methane is several different sources, and hydrothermal sources. It can come from a magmatic source. One of the volatiles that is produced from axial chamber magmatics is methane, in addition to carbon dioxide and hydrogen. But here we expect the methane to be sourced from life. So if we found methane, that would be a region of methanogens, bacteria that produce methane, or it could be a region of other organisms that have accumulated and are decaying presumably by methanogens. Methane is, like I said, it's associated with hydrothermal vent activity because it's one of the volatiles that's produced from a magma chamber. But in this setting, we expect that volatile to have been associated into the sediment that the hydrothermal water has gone through by the time it got to the seafloor. A few days ago when we were exploring, we found that there was no methane anomaly where we mapped, and the hydrothermal vent system that we were expecting to find, that was about 500 meters below the sediment. So in order for that fluid to get to the seafloor, it would have had to go through 500 meters of sediment, which effectively is a 500 meter filter. So a lot of reactives would have been consumed. But a hydrothermal vent site is a site which is great for life to thrive on, because there are some chemicals, and that there's a temperature anomaly, and locals can use that as a source of energy. And so we would get methane produced along the hydrothermal column that exists between the buried hydrothermal vent where it's discharged. That methane that does get absorbed by the sediment, it could get absorbed by life, and then recreated by other life, methanogens that are buried. So we'd be seeing a secondary life-produced methane, but we haven't seen any. Not yet. Not here. So this is a good example of the pillow basalt. Part of the weathering tendency of these is what's called onioning. Just after the pillow basalt forms, it weathers from the outside in. Also, some of the internal structure that you see there, that's from the lava coming from, probably, assuming that this is an in-place pillow basalt, let's just assume it's in place. The the magma would come from within and work its way outwards, and then that's what looks like a mouth there. That was a location where everything above the mouth was lava that was moving upwards and cooling, and then everything below the mouth was lava that was moving downwards and cooling. So that pillow basalt probably would have grew towards your point of view right now. would grew until the lava cooled to a point where it's hard and brittle and prevented the liquid lava from going further. It would have to go elsewhere, following the path of least resistance. It's interesting how some of these rocky features exist in our field of view and some of them not. Rocks, these ones would have a tendency to come from above and roll or fall down. They would do that intermittently across hundreds or thousands of years. Tyler, can you zoom in on that one again? Let's see like the perspective of where we're at. So it looks like we have some time. Let's go to 19. And after 19, what I'd like to do is explore the inside of this wall right here after we go to 19. If we want to do it waypoint style, what I would do is waypoint up here and then one up to the northeast. Yeah, but really I want to fly until we find the interior of the crater wall, because there should be a significant crater wall there, and then we just follow that crater wall around. Cool. So
Nancy, where would you like us to put the waypoints and set those up for us?
Well, I don't really know exactly yet. The destination is just along the interior of the crater wall, so we can put them just like a preliminary waypoint 20. That's fine, and then I think 45 should go to the east and to the south a little bit, just like on the inside of what you see the dark black structure.
Yeah, just
I think
rough spots that
Yeah,
we can
yeah.
kind of go with. Cool.
So now we're at the nearing the summit of the Capuche volcano. It's it has a ring-like rim of the caldera. It's not a complete ring. There's one corner that's not very prominent. Then it also has a central peak in the center of this caldera, which we explored earlier. So we're making our way to some waypoints to that on paper look like they give a good track of what this volcano is. We cover a lot of surface area as much as possible in the time that we're given. So originally, thousands of years ago, up to 40,000 years when this volcano was formed, potentially much younger, none of the sediment was here. So this is all stuff that's slowly accumulated. On average in the region, the sedimentation rate is somewhere between 1 to 3 meters per 1,000 years. Do we have something really long? A long stick or something? That's the longest thing that we have.
In terms of stuff that we can pull off, yeah. But we don't have a ton of range on that.
Okay.
I mean, like just length as an object, or how far out we can go?
I just mean something to stick in the mud to see how thick the sediment is.
Yeah, that's the best we got.
Okay, do you want to get a coral here? Yeah. We already have 4. Oh, I mean the coral. No. Okay. Okay, the one that looks like an anemone? Yeah. Not that one? The octocoral? You want the octocoral? Okay. Alright. Let's grab this coral. Yeah, the long octocoral. Okay. Yeah, let's get a good zoom in on it and get a good view of this garden.
How much do you guys want? Just like a little bit off the top?
What do you mean?
Coral bugger size?
The-
Bug size.
Oh, how long, how much length?
Okay, small. That's fair enough to learn on the rock. How's that hanging out while you get the rope sorted? Ran through it.
Is that kind of girl?
It's that level. Pretty pleased. Good work. That's the worst thing that happened. Just ran coming out. I think I'm gonna try to remove that. Yeah, you think you're gonna try to do something like that? It's nice. It's a nice idea. Kind of weird twist. Yeah, can you do that? See how this goes.
corals? Look at it right there.
No, coral, this one, coral goes here, coral river, because it's just a small piece.
All right, so what we're doing is we're collecting a piece of the octocoral, which is the long stalk-like coral that's in the foreground now. We're approaching. In the background, it's a sea urchin, the purple circle. There's some sea anemones. Sea anemones are the fangy-looking mouths. What's interesting is the it looks like there's barnacles on the rock, on the basalt, and they're all facing one side. Not all of them. Well, yeah, they do tend to be facing one direction. So that could say something about what the prevailing water currents tend to be.
Close-ups first?
Yeah, let's document this. Yep. So it's an octocoral. So you see, there's it's relatively fractalized. So the stalk has these. What? Octocoral.
Okay. Leave something a bit more optical. You're gonna have to look at someone who's
Is there a species name? Or
It's a seeped. It's an octagon, but maybe a seeped.
the bifurcated structure.
That's why
It's the line
but
of
it's fine.
truncated,
Polite is
bifurcated, or the
If you had a relative degree, you'd be taking because I wouldn't be able to dispute you at all.
Yeah, I think it's just a shot. It's fine.
Oh, no sample?
No sample.
Okay.
Because I think it's no sample. Just a shot is perfect.
Okay.
Because the colleagues can analyze the characteristic.
All right.
Thank you.
You're saying our
No more sampling.
photography is so beautiful. we
That's
don't need a
right.
sample.
Yeah, our photons are so good that
I think it's
we don't need to take a sample.
Yeah, that's why it's
The detail's amazing.
it's this one. It's very simple.
How can I open one of these?
So we are waiting for the black one. The one which let's see.
The lasers.
Lasers.
This is that's what is perfect. Thank you. That is perfect for my design. Good.
Yep.
Oh, you got
You captured pictures?
Yes, I did it.
So on this occasion, it was decided that we would not sample, and just the visual that we got was good enough, which says something about how awesome the camera is that we have.
I think you already collect.
So this is a good view of a fauna community on the seafloor on Capuche Volcano in the Chile Triple Junction region off the west coast of Chile. We're moving on to our next waypoint. And this region is approximately the summit of the volcano. The rocks that you see here, these are more pillow basalts. Most of the rock outcropping that I've seen has been pillow basalts. What pillow basalts are is when lava flows from its source inside through a dike, usually from the magma chamber to the seafloor. Then when it approaches the seafloor, as it interacts with the seafloor, it forms a bulb-like structure because of cooling. The cooling interaction with water is what causes the pillow basalt to be pillow-like. There was one other location where it looked like there was evidence of either a lava column, like a lava structure that's banded, that is usually associated with what's called lobate flow. So pillow basalts tend to form at the end of flows. Lava will, in this case, came from a higher source, and then after it was discharged from the volcano, it flowed downwards, and the downward terminus of each one of those lava flows became a pillow basalt structure. And sometimes you can have mounds of these, and they're called pillow basalt mounds. You can have lava flowing, and then it just forms pillow basalts like a forward-moving monster. But when the volcanic event ends, and the lava might drain back to the source it came from, or some of it, or it drains away, then whatever the lava has interacted with along the way in the lava chamber, the lava tube, it would show evidence of the lava level rising and then decreasing. So sometimes we'll see what appear to be columns that are banded. Like it looks like layers of basalt. But possibly what happened is that the basalt flow interacted with a wall that was limiting the spatial direction of the lava, and as the lava decreased in height, it formed a shell above it. And then as the lava flowed away, the shell broke and then it formed another shell just below it. Then as the lava flowed away a little bit more, that shell broke, and then the lava formed a new shell.
Waypoint 19. You want to test here?
Yeah, do a temperature.
There's definitely some gravity action. I mean, I can hear it. Leave it here. I'm just going to use some words. How about that? Oh, that's fine. Go ahead and move towards right now. You should do it. That's fine. It's a nice shot, actually, Jimbo.
I just got smacked. I saw that.
Alright, what's that temperature?
Okay.
Alright, temperature we got. Okay, same as ambient. Okay. Thank you.
Alright. Oh.
So here what we're going to look for is the inside rim of a caldera. When you flip around and go towards 20. Not exactly sure where it's going to be because I don't know how well this colors correspond to reality on the map.
Yeah. We'll find out.
Yeah. Lots of stirred up particles and green lasers. The green lasers are 10 centimeters apart, is that right?
Correct.
10 centimeters apart, and they're green because green transmits through seawater very, very well compared to other wavelengths of light. In fact, seawater is the most transparent to a spectrum of light that we used to see, and green is it happens to be that's the wavelength of greatest intensity from the sun, based on the sun's temperature, and also that's the wavelength that allows light to the greatest transmission through seawater.
Yeah, you want to start with?
Thanks.
Okay.
Geologically, the structure has so far been showing basalt as its lava type, and we see pillow basalts, the broken fragments of them in front of us. They tend to have a characteristic fracturing. That one in front of us that you could see, it looks almost columnar. When the pillow basalts form, hot lava is interacting with the seawater and cools down from the outside in. And when it does so, the outside rock contracts, and that causes stresses that form across the rock. And the rock might not fracture right at that moment that they interact with the seawater, but the beginnings of fractures that would cause the basalt to break are formed. Are these two plotted up on this yet?
Those are two separate.
Okay. one of the curiosities that I have is how the sea life that we see interacts with itself differently based on whether there's floodlights shining on it or in complete dark. Naturally, there's no light here. This area is completely black. It gets effectively 0 photons from the sun. And the only light that comes here is from us. I can't think of any other source of light. When there's a lava flow and there's an eruption that causes pill basalts, maybe the lava's a little bit red. Some of the life down here may bioluminesce, but I don't know about that. And what we're seeing is these organisms, but we're seeing them on our terms of intense light. And this is something that they're never exposed to. So there's a chance that the way they behave now is different from how it would be if we were completely in the dark. And they could sense us. The intensity of light that we shine on them is millions of times stronger than what they're designed to sense. And they can see us from further away than we could see them, because the light that we use to reflect off sea cucumbers and sea stars and the seafloor, we have to produce that, and so it goes through the water twice. It goes from the floodlights to the animal and then back. So it goes through it goes through the water twice, and then effectively it has 2 opportunities to become dim. But the fish, or whatever organism that's away from the RV, the light only goes through that body of water once, and so they could be twice as far from us. And the light would hit them with the same intensity as we would see something that's half as far as the fish. So this is a variety of what's called a ratfish, rat-tailed fish. We've seen a few of these down here. They're common in benthic regions.
Doesn't adjust well for lighting changes.
There's another sea cucumber to the right.
Not much. We just added 2 wavelengths that are super solar wavelengths. When we were on the today, I know. One off the rails, just doing tricks. Nuts. You wouldn't believe the results was we see. Really? Cool ones, different ones, or? Yeah.
You got the frozen starboard, so it's up. That's something that wants to use on you. You're looking extra sharp. Wait, you want me to say that?
No. What about the octopus? What about octopus?
Which one?
Yeah, so many. So many, apparently, so many. Many octopus. Best octopus. Everybody's talking about this. The morning edition of newspapers full. Talking say archivists.
One of the things that we used to conclude the possibility that hydrothermal vents could be in this region was, oh, look at that, was the presence of helium-3.
Did we do Bridgeport yet? Is there, no?
No, we're doing that at the end. Unfortunately, helium-3 is it's a difficult difficult atom to measure. If you want to measure the ratio of helium-3 to helium-4, then you have to have very precise equipment. But what it would give you in this setting is, if I just had a helium-3 to helium-4 measuring tool, it would allow us to sniff around for water that had a mantle source. Because much of the ocean has the helium-3 to helium-4 ratio, the helium content, is determined by the atmosphere and what's in the atmosphere. The gases in the atmosphere diffuse into the ocean, and the ocean currents bring down from the surface to the bottom of the ocean. So the ocean has a background helium-3 to 4 ratio and a background helium content, but the water that's discharged from hydrothermal vents is very different. It's about 8 times the helium-3 to helium-4 ratio of air. Essentially, it has its own helium-3 to helium-4 fingerprint. So if we had such a sensor, we could, on the fly, sniff around for evidence of hydrothermal vents and source of chemosynthetic life.
Did you see the little rock outcrop over here? Alright. Anything else is?
Yeah, so what the goal is here is there's these 2 waypoints, but there's the rim of a caldera up here. I'm not exactly sure where it is, but I just want to approach the caldera and the image is as a rim. So I want to find the rim and then go on the inside of the rim where it interfaces with the.
Do you want to go look at this little rock outcrop, or keep going?
Yeah, go there.
Yeah.
Go there. So what do you call that? Side scanning sonar?
It's a scanning sonar.
Scanning sonar?
Yeah, that one.
So we have equipment, sonar equipment that we can use to look beyond what we can see visually with photons. So we have scanning sonar that uses sound waves that travel through water, and that allows us to see if there's a wall, for example, or a structure of different sonic velocity, and that allows us to look further, except look further with sound. So I guess one could say that the scanning sonar is like our external organ that we use to echolocate structures that are beyond sight. Often in caldera settings, if there is a hydrothermal vent activity, it will be within the caldera. It will be on the inner rim of the caldera, not necessarily right in the center. of the caldera, but oftentimes these calderas are flattish, and then when they approach the rim, there's a protuberant rim that goes around the caldera, and the interior of that rim is a known hotspot for hydrothermal vents. One example is the axial seamount. Another one is others. Others volcano. Yeah, so let's explore this. Let's look at the base of it, go up it a bit, and see how far it goes to the right.
Okay.
How far do you think the structure was? Was it very far up here?
No, it looked like it was kind of an isolated thing, but
Okay.
I mean, sometimes you can't tell from the sonar, you know.
Yeah.
It did look like it was probably
Alright.
about 30 meters long-ish.
Okay. Is it closed anemone?
And so you seen anything interesting geologically around here?
Yeah. These are all pillow basalts, so we're seeing the same kind of lithology that we've been seeing. It doesn't. I can't tell if it's a different, like a different lithology. To me, it just looks like basalt. It's a similar color. We'll find out when we collect the samples.
Yeah, we were bringing a bunch up, huh? You seen any evidence of venting new or ancient?
No, there hasn't been. There hasn't been evidence of venting. We measured the temperature in a few places, and our probe is shallow, but we haven't seen anything yet of interest. Or
So now it's kind of, I guess we're up on a little plateau. So.
okay, yeah, I would go back to where we came from and go on the inside of that rock structure.
Okay.
I guess the idea is to study this area around there on the inside of that one.
So you try and follow it to the north, kind of?
Yeah. I think we're probably on top of this rim right now, and I just want to go down to the inner wall of it.
Kind of like those hills, too.
There was one time earlier, it looked like there was what are called lava pillars, which is like what form from when there's a lava flow that reduces in height. It's like clear evidence of lava flowing through a chamber. I haven't seen any since that was earlier today. So we're spending some time looking at the inner wall of the volcano now. Yeah, have a look down slope of that and see what's down there. That's just where we came from, isn't it?
Yeah, I'm heading back to where.
so you can see that we're going through our trail that we made when we came here.
What's that? Okay. Moving north. No, I'll keep them to the south of you, but.
Yeah.
You're going up towards 21, yeah?
Yes.
Great, RV, got a new waypoint? Very waypoint.
Is that something up there?
Yeah. Yeah.
Try going down to the base of this rim a little bit more to the right. We don't have to follow the waypoints exactly. It's just like an arbitrary path along which we can use to hopefully find the inside of the wall. And what I'm looking for is the rock outcrops that might exist on the inside of it.
Looks like we're about to run into something. Keep going, huh? See on the sonar?
Okay. Yeah. You think it's real?
Yeah.
It's something. It doesn't look huge, but it definitely looks rocky.
All right.
You want to see that?
Yep.
Looks like rocks and then maybe it drops off.
And
Okay.
you can see it drop off in your right side. As the
It
rocks
just
coming
drops
in
off
there.
or it's sheer. So it probably drops off.
Interesting.
So you want me to go the drop off or the rocks?
Yeah, follow that rim. Yeah, follow the. Do what we're doing now. Just follow that contour.
Yeah.
And can you rotate the ROV so we're looking
Yeah.
at the into the slope? That's good. Just mosey along.
So that camera Errol was asking about.
Yeah.
That was a spare camera that the Falcon had.
The spare.
Yeah.
So it doesn't go on.
So these are all pillow butts off
Well-
still. Some of them larger than
Yeah,
others.
the one on the Falcon right now
And occasionally the pillow basalt, when the lava interacts with the water, it cools down and forms a thick shell where the inside might still be liquid. And that's why some of them are hollow in the middle.
So when I was
Like
testing
the one
last-
example,
Sure.
I don't know if that's a good
You
example.
turn on and then as soon as you
Yeah, there we go.
turn it
The
on,
example right in the foreground, right in the middle.
into the
So that one has a little hollow center in it. That's probably where the remaining lava flowed away somewhere else. And you can see that on these pillow basalts there tends to be like columnar structures from the outside inward. And that's
So you could use the Falcon right now with no problem, it's just the atmosphere.
correlates with
Yeah.
the temperature gradient. Where the outside was the coolest temperature and the inside was the warmest temperature. And as the outside cooled, it contracted, formed little hexagons or other shapes, other polygons. There were cracks, like mud cracks. Then as the rock cooled inwards, those cracks propagated to the interior, and that's why you see those columnar joints. There's another example where possibly the center of the pillow basalt flowed elsewhere after the shell was formed. It's a green spoonworm. They have that's the female. That green animal there, so that's the female, and then the male is a little creature that lives inside the proboscis. Let's see what else we got room. We got room for some rocks.
Yeah, that's usually fireboxes and here and
Okay. Let's keep moseying. Yeah. How large of a rock can we sample?
How much room we got on the porch is really the thing. Do we have,
these are empty.
we got a brown box that's empty? We got that thing on the left too, right? Is there something in there? Great.
Oh, inside here, that's empty. So, well, there's no water sampler in there anymore.
So then your main limiting factor would be what you can get in the jaws, you know, it's open belt like this.
Well, how about that rock that it looks like it captures the ropey structure. It has like
Stay
has
there.
mud all over it right now. But
So in
just a little bit to the
see
right.
about like this? That's
Okay.
about your jaw
Or
size.
I think there's one piece that's over there like that. Over to the right some.
Yeah.
You see how some of this has like stripes on it? Is that like the lava doing that?
Let me see.
You know what I mean?
Yeah, I know what you mean. There is a lava flow mechanism that causes stripes on things. If there's lava going up the side of something, like flowing up against a wall, then as the lava flows away, it tends to leave like a stripy, fingerprint like along the wall that it used to form. Because at each height, it forms a hard shell on top. But then that thin shell breaks as it goes down. Yeah, there was something right inside here. It looked like it captured the ropey. Yes, this one here. That looks like a stick.
Just bring your arm up. Here, start around. Near your arms up.
Sure.
Just
Volcanics can be very
the
complex.
high temperature curve with
Pill
the
basalts are the
arm.
most common thing, but there is just all different sorts of morphologies.
So I will bring your arm up.
Sure. Can you look at it?
Which is to say, there's all sorts of structures of rock, shapes that form from the cooling of it.
Yeah.
Sometimes the lava can appear wrinkled.
Oh, wait.
Oh,
Yeah, it's retracting mechanism as fluid.
With pill basalts, maybe there's some parts that
This is the only one we have. Really?
Yeah, what you could do is put it on the
form stringy.
short.
There's Pahoehoe. There's one kind of lava. It forms a very hot, very fluid lava, and it looks. Some people call it ropey lava, but it looks like folded fabric. Sometimes lava can drip out in tubes.
Just watch the L. See where my arm's kind of sticking out at the top. You guys can see that a little bit. Like that.
What I'm saying, you could probably place it right there.
I'm not gonna need it right now.
Or you're gonna use to pick up your rock, right?
No, it depends. Probably the other one's better for rock.
Yeah, well, the gas tight is on that one.
Right.
You get gas tight now. There you go. Alright.
In front of us, we see a pillow basalt that's unbroken, and then adjacent to it, another one that is.
That might be good, something like that.
Oh, the rock. There was one off. I think. Oh, did that break off just right now? There was one off to the right that was a little more. Maybe we missed it. I think the sediment obscured it.
And maybe some of these are loose chunks. It's hard to say.
Yeah. What about down there at the bottom, like that? It looks like like some lava that might have fractured like that, but it looks like a small branch of lava. So this is a very complex lava situation. It looks like it's mostly in situ, which is to say that this is what the lava initially interacted with the ocean. One of the reasons why I think it's in situ is the rock that you see right in the center. It's has a very which one? Yeah. Oh, do you think this is too big for their claw?
Now we could try it out. See that one looking like a loose piece in there, maybe. I don't know.
Okay. I wanted to capture the structure of it.
Okay.
So I think see if we can see, and down these ones here too. It looks like the lava didn't just form a pillow, but formed like a rope or like a tube.
You probably gotta hop over for me to get that, or I can use the port arm.
Yeah, you could try to pull it on.
Another 50 go maybe.
So these structures are relatively delicate. If they, that's why I think that they're in place. If they form from above and then fell down, what we'd see is a pile of debris and the interiors, the insides of broken rocks. But here, these are the outsides of the pillows. There you go. That moves.
Yeah.
know, it might have been sitting there for thousands of years. Good work.
Where's this going?
Let's see, we have room in EV3B.
Or do you want to put in that thing on the side?
Will it fit over here?
No, the far left.
Sure, yeah, you go there.
You don't have to use the bow box?
Yeah, that's fine.
So you can see the code again. There was always in the future.
Yeah, all different. You identify
Yeah, possibly. Yeah, we can go over that. Right now, I'm looking at the inside of the. Yeah, we did all of this. There was a problem waypoint that went way out here. I think there's like a translation. And we went all the way here. And we came here, and then we're somewhere around the inside of this. I wanted to look at the inside of this rim right here, so that's what we're doing.
That's what we did yesterday.
Of this one?
Yeah.
Yeah.
We can continue through there.
Yeah, it was the most.
I'll find new waypoints.
Okay.
And we don't do the push coring yet because it's too early.
Right, yeah. So all the push coring we're going to save till the very end.
In crater, yeah.
That's right.
Yeah, it's too early for that.
And also
Otherwise the RV is going to be quite heavy.
and then also the other biological samples we want to collect.
Well, we can connect. Are we done with corals? Are we okay with corals? What? Are we done with corals? No.
You're anything.
Okay. The coral creepers are all.
No, there's one and I think number 8.
Okay. So maybe while we are in the crater, Tim,
Yep.
you can collect the coral.
Great, yeah, that's rad.
She's here so she can tell me what she needs.
Uh-huh.
And I'll find you waypoints.
Okay, let's do that. Yes? Oh, there's already a sample in there?
Yeah, that's why we now put that sample.
RB1.
Just say port rock box. Port rock box. Yeah.
Oh, so you're looking for the name of it?
Yeah, in
RB Rock Box. The location?
the cielo.
You show me. Okay. RB.
Yeah, what RB is that?
Is it, there's a.
RB1?
Oh, right. Oh, yeah. Hey, good point, good point. Which one would it be? So, RB1?
Yeah, just go RV1.
Okay.
Thanks for going.
Happy?
Oh, yeah. Was it put away?
Yeah, it's
Good,
on.
excellent. All right. All right, let's just continue along this wall.
Okay.
Oh, because we had to swap the consoles. It doesn't remember what valves are what. So you write down so you know which valves. With the mini quirks and suggestions.
Get rid of that code with the valve thing. Because normally what you would have is you have 3 rows. And they don't change. You know that when you have to change it. And that way everything's always the same. So you know this is always the
Here we're seeing more pillow basalts that are mostly in place. Sometimes they're fractured. Different sizes, different shapes. Oh yeah, some of the laminations on them, or what appear to be laminations, stripes, that could be from the formation of the pillow basalt as it was growing. As it proceeds into the water cools down the hard shell. It creates a hard shell around the lava that's pushing forth. And in order for the lava to continue pushing forth, that hard shell may open up and create something like a mouth. And then the lava would move out at 1 more centimeter, and then that would harden up, and then the shell would open up again, and that would continue until the interior lava doesn't have enough pressure to push it through anymore. So this is these are pillow basalts. This volcano's this volcano is very unique from other volcanoes in the Andes. It's in the Chile. It's in the Chile Triple Junction, which is oceanic crust. It's the location of where new oceanic crust is forming. So in this central valley of the Chile Triple Junction, there's a name for that, the axial valley. It's called Section 1 of the Chile Rise. And inside Section 1, right down the middle, that's where rock is of minimal age. And then as time goes on, in the axial valley, new rock will be formed, and through a mechanism associated with being a divergent plate boundary, which is where 2 plates are formed. They diverge away from each other. And that line along, that marks the genesis of the divergence. That's where the youngest rock is. And as that rock gets pushed off to the side, 1,000 years later, slowly at the growth rate of a fingernail, it becomes a little bit older. Another 1,000 years goes by, and 1,000 years go by, and 1,000,000 years go by. And these divergent plate boundaries create basaltic rock that can be very old. Wow, look at that. These are the interiors of pillow basalts. When pillow basalts form, they push into the water, into the seawater. And as they cool, fractures form. And those fractures weaken the rock and make it so that the noses of the rock, the round fronts that used to be there, fall off. And what you have, it looks like tusks that have been broken off. But on each one of those, what appear to be broken faces, there used to be a round pillow protruding, but now it's fallen down. So we're looking here because it's on the inside of a caldera. It's a slightly protected region. There's a rim that surrounds where we are now, and so it creates its own system of ocean currents and can potentially form a a sediment trap and a biological trap. A location where there may be endemic species. And also, with regard to the search for hydrothermal vents, the interiors of caldera walls tend to be the locations where we find hydrothermal venting. There's some brittle stars. So sometimes you see coloration on the inside of these broken rock spaces, and that's because of chemical weathering. Looks like we're starting to see some barnacles. Oh, wow. Let's look at that for a bit. You want that?
It's sponge. I mean, it's
Is it coral or sponge?
sponge.
Oh, okay. So we have room for one more sponge. Do we have that sponge yet?
No, we don't have it. We have the lollipop.
Okay, so we can get this one.
Yeah.
Okay.
Okay, the reason can have it's big, so we can take but then we need to center because of the sediment,
Okay.
and then
Okay, so should we?
if they can, otherwise it is impossible. We don't
Okay.
manage to
So ideally we should park here and wait until the sediment is okay.
if it's possible. So now, otherwise we will search for another one. I already saw this one, another place. Let's see what the one is.
Okay.
Talk to them and see.
The small one up there would be that small one.
Yeah, well, shouldn't the body should go in and should be like this.
Okay. So maybe that little one right
Yeah.
there. That'll work.
Or the branch, that branch, you see, those branch that are
Or
bigger.
just take that.
Yeah,
Okay.
the two of them.
All right.
Let's see what they say.
Is it possible to stop and wait for the sediment to go down and then snip off a bit of that? So what we're looking for is there's the two branches off to the right.
Sure.
Just get those two.
Okay.
Is that good?
It looks like there's an isopod on this tree, huh?
Yeah.
Yeah, it does look like the structure of the sponge is created to be used by other life. I'm sure there's lots of creatures that would make a home inside there.
You're getting tugged a little bit?
No. Does he have no close one?
Where are you gonna want these to go in a
BB for A.
BB.
We want that we were
BB4A?
BB, sorry.
Just zoom out on
Is there really?
side camera. Right?
What's that?
Just zoom out on the side camera.
Zoom out on the side. I think that is some depth.
Looks like it's hard to get a scenario where there's not sediment. Good. All right, cool.
Okay.
Hold on, I'm moving.
wait, hold on a second.
Hold on.
Do you want to get a good visual on it with the camera before we do this? Okay.
Alright.
I'm talking about
Those, yeah.
this piece here.
Yeah.
Just kind of there.
Yeah.
Is that enough?
Yeah, it's
Let's
good.
take those and then we see. They can cut it both. I think. One. Now we see another.
Okay.
Structure is super nice. Thank you.
Torch down.
Yeah.
What's the name for that? Do you know the name for that type of fund?
Is it 4A?
Yeah. BB14.
There's a question, someone asked if we can pick up bioluminescence with what we have. Right now, I don't think we do. We have a sensor that shines light into the water and measures how much light comes back, and that's a turbidity sensor.
10.
And that's a turbidity sensor. The more
Might be a little.
particles you have in the water, the more photons it reflects back to a sensor. To detect bioluminescence, what we do is we have an instrument called a fluorometer, and what it does is it has an LED on it that shines light into the water at one wavelength, and there's creatures out there that will absorb that wavelength and then re-emit it, but as a different wavelength. So there's an instrument called a fluorometer that may produce red light and then shine it, and it would come back as a different color. And so there's a red emitter, or sorry, one color emitter and then a different color receiver. So there's no ambiguity associated with the emitted light and the sensor light from the instrument. But we don't have that. Not now. The ship does have a CTD rosette, which is a package of instruments that senses bioluminescence and captures water and measures turbidity and salinity and temperature. But that's on what's called a wireline system. So that's lowered from the ship from a crane through the water column. And then the Niskin bottles will sample water, and that one does happen to have a fluorometer on it. So you can can map the change in bioluminescence that occurs as the sensor goes through the water column from the surface to whatever depth we choose to study. Is that how long?
No, I just know that the glass is sponge, but exactly which species.
What was that?
We would go
Alright. Has anybody logged for biology sample?
Yeah.
Is on. If you could put the temperatures on so 180 because the base of the tie down is kind of like boosted. You took a look. Maybe you live to in 180 instead.
Oh, it's not hitting it, see? And it doesn't move when you go down, that stays in the same spot, you know what I mean?
Today, one of the things we're looking for is evidence of hydrothermal vents. The other thing is, all right, let's go up to.
No.
Oh, no. Oh, Niskin bottle. That's right. Okay.
Sorry.
Yeah, Niskin. Let's do Niskin 5.
No, yeah.
Yep.
Waves there.
Fired.
Hold on. Okay, it's fired.
Okay. Thank you.
New frame.
You said we're gonna go,
Let's continue along this wall until we get close to waypoint 21.
more towards 21?
Yep. Bye-bye, sponge.
keep following it,
Yep, yep.
go back down towards your line, any other line.
No, just keep following this cliff.
Okay.
So this is the first time that this region has been explored like this in this detail. So what we're looking for is we're looking to characterize the fauna that exists here. This region has not been characterized, has not been mapped before with regard to what animals live here and which ones do not. So it has been a great unknown. Surely life has existed, but it was unknown to us. The population density was not known. The ratios of the different fauna was not known. And this expedition is to bring the mysteries of the Chile Triple Junction to light. Do you know if we have what? There we see a symbiont. Looks like a sea anemone growing on a coral. Or, if nothing else, it's a opportunistic home for the sea anemone to get away into the high water for an easy feed. So these rocks here, these are rocks appear to be characteristic of spreading center volcanism. Across the world, there's thousands of kilometers of spreading centers, which is where new oceanic crust is forming. There's spreading centers networks that extend from the Southern Ocean all the way up to all the way up to the Arctic, through the Atlantic, through the Indian Ocean, through the Pacific, and the rock type that is characteristic of spreading centers are called mid-ocean ridge basalts. And they tend to have despite where they are across the world, they tend to have a characteristic chemical composition. Yes?
How far north do you think we're going to go here? Just trying to decide whether to move the boat again or not.
Just to 21 for now.
Oh, 21.
Around there.
Actually moving away from
North.
it because I'm following.
This is good. Well, let's keep following this. This is interesting.
Okay, so I should go ahead and move the boat then a little?
A little bit, yeah.
Bridge, RV, waypoint.
So there's colorations on the inside of these rocks. There's a couple different mechanisms that cause colorations like that. One of them is that if the rock is, when it's exposed to seawater, as soon as it's exposed to seawater, it starts chemically reacting. And then that water-rock interaction takes some time to penetrate into the rock from the exterior. And so you end up with the rock being altered on the outside, on its shells, but on the interior, not so much. And then when the rock is broken open, you see that. You see a less altered interior and then a more altered exterior, which had been closer to the seawater. And you see rings. That's one mechanism. Another mechanism is when the rock is formed, when the pillow basalt is formed, the cooling lava interacts with seawater, and it interacts with itself in unique ways as it cools down. And so you might have rings of different mineral composition. For example, when the rock is chilled immediately, on these rocks it might form a glassy surface, but around here I'd expect that to be at most like a millimeter or two thick. The interiors of some of these basalts, these pillow basalts, are empty. There's holes in them, and that's because when the pillow basalts formed, they were effectively a shell. And pillow basalts form when lava flows downhill from somewhere else. So as the lava is flowing downhill, it forms pillow basalts, and then if it forms a blob of hard shell that it can't poke through anymore, then it will just go elsewhere off to the side. And so these pillow basalts grow downhill.
We could try that sometime today if we want. Maybe on the recovery. I'll see if we have that kind of twisted too.
So this is more fractured terrain. Some of these came from up above, higher in the caldera. But these sponges that we see, they've been associated with basalt. In the more pelagic settings, where all we see is sediment and relatively flat ground, we don't see those sponges so much. Here you can see some possibly more emplaced pillow basalts with empty interiors that have flowed away after the shell was formed. Did we hit something? Looks like there's a little octopus off in the distance. Sea anemone, a green spoonworm. The green spoonworm is the female.
the Campion male that exists inside its spoon-like.
So if you look, right now I'm making a circle, right? So
Okay.
kind of going around a mountain, probably.
Okay.
So you want me to head back to 21 or continue?
Let's see.
You see I'm making
Yeah, I see what you're doing.
So it's just a mound I'm going around here. It's probably not mound there.
Okay.
Where that yellow.
Yeah, so you're
Yeah,
about,
that's what I'm
right
playing
here.
around right now.
Okay, well, it looks like I'm trying to determine how much of this we covered already. Okay, just continue to do that.
Could you put the hourly snail trail on that?
Yeah, let's see. This could be. Okay, you're on the outside now. Yeah, come around here and let's have a look on the inside like that.
Okay. So which way is that?
I think it's to your starboard. Just keep.
Yeah, keep going and do it.
Yeah.
Okay. So yeah, that's the snail trail up there already.
Right.
Thank you.
Keep
That's
going.
awesome.
Keep going, start, right?
Yeah.
Bridge RV, New Whitlam.
You wait, wait.
You're trashing that blue van.
You have the power.
Here we see more mixed communities, barnacles, brittle stars. Pillow basalts. Some pillow basalts have layered-like features on the outside, and that's because of the way that they expand.
You got almost a turn in now.
Yeah.
Just do that before. Just has some.
When you come further south, you can pull the
First time.
come down this way.
Yeah.
Here as well.
Rocks and rocks.
And then maybe end up here, just right.
What do you mean? You go down? Back up again?
No, just go over here and then just go along the beach.
How would we do it?
Yeah, we have to go straight up.
Come on.
Either from here or just. We have to fly high. Forward, no, yeah.
Fly over.
Then we have to do it from here. Yeah, we have to go from here to here.
Bridge RV, New Whitlam.
It's more
New
efficient.
waypoint.
That'd be interesting. Yeah.
Send the waypoint. Is it okay?
Okay, so it's updating on that map.
Mm. So, like I'm top of it right now.
Okay, so let's fly over where the outcrop is. Looks like the very peak. And just have a focus on the rock outcrop and see if we could see any the tops of peaks can be locations for fluid discharge, and those locations there might be communities. Oh, that's unique. It's a good starfish. This is an interesting garden of benthic fauna. Starfish has apparently responded to our presence. Yeah, have a look up inside there. We're now at the peak of one side of the rim of the crater of Capuche volcano. We're looking to characterize the life that exists down here that's never been seen before. We're looking for locations where hydrothermal fluid may exist so that we can explore the so we can learn more about the types of chemosynthetic communities here, if such hydrothermal events exist. What's that? Oh. Let's get a look around it like that.
I'm gonna actually go counterclock instead.
Okay, cool, okay. Looks like that's a sea spider. Haven't seen too many of those. Sediment. All right. Looks like the current's just going to make it look dirty. Okay, so what if we're going to get new waypoints for going down here.
Mm-hmm.
Until then, what if we explore the rest of this wall right there? come back down until we get to like the base of it, assuming that this map is correct.
Yeah.
I think I was getting off just before it got sent. Okay.
Yeah, the rock is up to 40,000 years old. I wouldn't say it's any more than that. The estimation of the upper limit of the rock is determined by its distance from the center of the axis, where two new tectonic plates are being formed. And this volcano is about 1.4 kilometers away from the central axis. 1.4 kilometers, it has 1,400,000 millimeters in it. And each side of the spreading center diverges away from the central axis at a rate of about 35 millimeters per year. So 35 goes into 1,400,000, 40,000 times. So that means that where the volcano is now, approximately 40,000 years ago, it would have been in the middle of the axis. So this volcano, as far as I know currently, it could have been formed anytime from 40,000 years or more recently. It's like an analogy of that is to say that you can only be as old as your mom and no older.
No. Going down.
So the age of your mom is definitely an upper limit on how old you can be.
Yeah.
So you're probably in, the analogy breaks down because in humans we have to wait till our moms get to be grown up before we're born, but it's a way of visualizing how there's a mechanism that gives the volcano an oldest possible age. Now it could have formed at the central axis and then has been pushed away across the past 40,000 years, or it could have come in more recently.
Talk about it in the meeting, but probably want to get off bottom line. So now it's starting to blow around 1, and by 4 it's actually bad.
Yeah, we're going until
That way it can be up to 4. And then it gets really good. Yeah, that's the best we've seen yet. So is it just 7?
It's just the same.
Yeah, it's just I've got to tell it, that's all. So it's not
There's a sea urchin. A sea cucumber. People call them sea pigs.
Keep in mind that how long it's going to take.
finish the what? The coral
Coral
sample?
sample?
Yeah, so we got 2 corals. Let's see, what else do we need?
We still need one for
Yeah,
here.
there's one here. There's another coral. Oh, who wants one? Anna, I don't think she wants another coral.
Okay.
Are you done for corals?
No, still at least one.
I will check like if I find another one that is so this one. Otherwise, okay. I still have one book.
Yeah. Let's just do that. I'll double check that's weird. Nothing that was supposed to be in this. I'll double check.
Okay.
Yeah, but I remove them. It's fine. Just
I can just take my.
just take them out.
So they can be back here.
Yeah, that's perfect. Ten or 11, right, Zach? Yeah. I'll talk to you just a minute.
Alright, so
Having 10 or 11 as a time to go off bottom, I think we just have to keep it a color and not go to a new point.
really?
Yeah.
Okay, cool. Then what I'll do is, where's my little pointy thing? Alright, then we did make the best of the time here. Maybe we'll just go on the inside of this rim up here
Yeah.
and just kind of continue around.
Okay.
It doesn't look like there's much over here.
I don't think we can go that far.
Okay, then I'll
Because we need to sample, well, as long as we see corals along the way.
We'll go to the extent of this inner wall then. So I'll go up to the extent
Okay.
there and then be like, okay, done. Then I'll come down. Is there a preferred waypoint for gathering the fish cores?
And he's near pillow lava basalts.
So it doesn't really matter. So there's not like one waypoint.
No, at least the 4 ones for Marble Lab need to be there.
At where? I don't. At which waypoint, do you know?
So it should be 4 push cores.
Yeah.
Yeah, it could be those, but it doesn't matter. So 4 push cores need to be really close. So both of them need to be, when you take them, they need to be close to each other as well. And those should be near the structures of the microbiology.
Okay, but is the location on that already determined? Or do we-
No, it just need to be when you see the structures. It needs to be there.
Near rocks.
Yeah, that have evidence of
With
lava flow.
Okay, with other fauna, like around communities.
No, that's fine. That's okay.
Alright, so just around rocks.
That's just around rocks. The thing is,
What about all the other, the 12 that we have?
the other ones have to be in soft bottom areas as well, but we can use it when, for example, we're picking up this 4. It might be used already, we can pick up 6, for example, and then move along and pick number 6.
Okay, so we got 4, and then we'll get 6 more, and then 6 more elsewhere.
So
Okay.
nearby, doesn't need to be exactly in the same spot.
Okay.
It's useful to have some spatial distribution as well. But keep in mind that push cores would be the last thing, so the reason probably take them anyway.
Okay, how long does it take to each push core? Or I mean, probably takes
That's fast.
5, 10, 15, 20, like that, minutes?
Yeah, 20 minutes is fine.
25, 30, 35, 40, 40, 50, 60, 70,
If you see a nice structure, if you go around and explore a little bit more, just don't forget, if you see this structure, just maybe take the 4.
Okay, yeah, we definitely
But don't
have-
take the rests yet, because then the RV is going to get quite heavy.
Okay. So I'll just take the 4 in one location, and I'll take these
Don't-
6 if I feel like
No,
it.
no, don't take this just
Okay.
yet.
This is
Just
the
go
only
to it
there, yeah.
towards the end. Focus on the coral sampling.
Alright, I'll get Jeff's. Look at Jeff's.
And the coral sampling and the sponge, if we see it.
What kind, is there a new kind of sponge that we need for coral?
If you see something different than these 2, you can put it here, for example.
Okay.
That's fine.
Okay, so a new kind of sponge and a new kind of coral.
Coral can go here.
And what about the spoon worms? Are those all done?
There's still a water bottle to take, and I will tell you. So when you collect the coral, you can collect water as well, but I will tell you how that is. It's fine.
And the corals go here?
first piece will go here. In the Rock River.
Alright.
But don't worry, no rush.
Alright, where are we at? Are we finding any rocks yet?
No. Down in the flats there, heading towards back to 21.
There's no rush answer.
Okay.
It's fine. We just don't go to the new waypoints.
Okay, definitely. So, let me see. So that looks like that's a structure right there.
Yeah.
Maybe you can come around and look at that.
Okay.
Maybe we can come around there and face all that.
And to like to the 50 meters this sorry, to port. That is port. Sorry, his port would be on this side. Red light somewhere here.
So where are we gonna end up?
So we're coming back like here and then turning in here. Just so the 50 meters bring it back. As a way across.
Can you turn to the turn to up here and see what's in that direction?
Okay.
Just visually.
Yeah, so you see something on the over here right now, right?
Yeah, I want to have a look on the inside of what's up here first, though, because we got halfway around it. I just want to continue the rest of the rim.
Okay, so where we going? Up, where we going?
Can you rotate our ROV clockwise?
Rotating.
Yep. Just have a look and see what's here.
Good.
Yeah, and I'll stop on some please and maybe do some shift around down here.
Nothing.
Yeah, there's just if you continue going straight, you start going up the hill.
Okay, interesting. All right, then let's come back down the slope. Then can we come back down like facing the slope?
Well, so I was following a line and then I started following the slope up and started going around, right? So I came back down to the flat area. So it's either I go back here and this way.
What'd you lose?
No.
No, I didn't lose anything.
Okay.
Or there's the vertical face here, that this piece you wanted me to look at.
Okay.
Going to the right.
Yep.
So
Okay,
if I come back here, and this was where if I continue in right, that'll be that ridge. But we ended up going up the wall.
All right. Well, then come look at this structure that we saw over here then briefly.
Okay.
Can't breakfast today, something.
Yeah, let me turn you to where you want to turn.
Well, how far this distance that the sonar is being
That's
shown
30
at?
meters.
So in reality that extends.
Sorry, 75 meters.
Okay, so that extends 1, 2, 3. Okay, so that's about accurate. Okay, so the visual representation is accurate of what it actually does scan.
Yeah. So you want to add to that?
Yeah, let's go here. Let's go up to that.
How's Alex probably? Okay, just go into that.
So looking for features or?
Yeah, looking for more rock, some more interfaces between the rim and the flat valley of the caldera. And once we find a rocky outcrop, then we can take some push course.
Wait, so you're talking about perpendicular to this face we see on the sonar, yeah?
Yeah, we explore that structure right there.
Yeah.
Yeah, so I'm just coming back to show off a bit. Bridge, Darby.
Go ahead.
Alright, that is an updated waypoint for you.
Did you just drink my coffee? Oh my god.
Sorry.
I'll just drink out of the other side, it's fine.
You almost spray some blade in there.
Wipe that down.
Did you drink out of it yet?
I did.
Oh.
My mustache is gonna start sprouting faster than
Yeah, finally.
Actually, it doesn't look like it's a rock outcrop.
No, it just looks like it has a mouth, maybe.
Okay. Alright.
Pull in the rain, but go a little further if you want to get
Let's go back, actually. Let's loop around. So, let's go back and look. We had some interesting structure right here. We can go back here and collect the. We can go back here and collect the push cords right here.
back where we were.
Sort of, yeah. So we looked at this. There's a face right here. So we were looking at some structure, a rock that was right here. Then we came around and we went back. I was going to look for the other side of this face, but I'm not seeing it. So I'm just going to come up and just see if we could extend that a little bit. There might be some rocks right there. There was before. So that shows that there's some structure right there. Is that right?
Yeah. Remember the RV's pitched down like 6 degrees, so it does pick up just not
The ground.
the sea. Yeah, the sea disappears, especially here with not as far.
Bridge ROV.
Go ahead.
You guys can come to a pause at no specific speed. We're gonna be good right here.
Okay, stop in a minute.
Thank you. Al.
So we're heading back near a previously known region of pill basalt outcrops. We explored around for more
basalt outcrops at the summit of the rim of this volcano, Capuche volcano. And we're using multibeam mapping to guide us in our exploration. But the multibeam mapping doesn't tell you what kind of rock is there, it just tells you the topography. So if you see a rim, then on a map it could be sediment, or it could be like a rock outcrop, you can't tell. So I'm looking to capture some push core samples near a volcanic rock outcrop in place as much as possible. All right, so that's just where we were before. We'll continue to follow that same path, and then
Just along the face of
yeah, yep. And then when we find like some good in situ, undisturbed salt, and we'll take some push cores.
That's fine. I just don't want to get numbers because it'll just stir it up and make push cores a mess. So you just hold it down a little bit to make it better.
Let's keep going. Just cruise around.
That's actually pretty epic.
So we're seeing pillow basalts here that looks like they came from above. These ones are not in place. These pillow basalts are look like mostly they're fallen fragments of an outcrop that's uphill. If we end up here,
Where we had stopped previously?
yeah, I think it's good. There's a good rocks there, and then we can take some push course there. It's good that you're going lower because we're seeing we're getting a new vantage point that we didn't have before. We're taking the push course. How flat does it need to be? Can we do that on this sloped terrain?
We can always try on the slope, and we can always try with like a test cord. If the slope is stable enough, then yeah. Or if it's deep enough and stable enough. Would you want it perpendicular to the slope, or?
It doesn't matter.
Yeah, we can always give it a try.
Crab and a coral. Do we have one of these yet?
Yeah. Yeah. If we don't find them, stop.
How achievable would be a push coring from here?
So what if I know?
Yep.
Don't you think that beyond the sediment would be up?
Well, everywhere that we probed, the probe has been able to penetrate deep everywhere. It does look. Let's go. Let's go around a little bit more up here.
Yeah, sweet. Bridge, Audi.
Go ahead.
Updated to wait platform for more.
Go ahead.
So it's some development.
That's it.
It's universal.
All right. Okay.
This looks good. Let's do this. How long are the push cores? How long are the push cores?
I wish there was like 30 centimeters.
That's pretty long. Four. So we want to do four. I want to choose a location where there's where they can penetrate as fully as possible, and where there's basalt. So it's tricky. This region might be good right here because it's right next to some basalt, and it in of itself is a sediments region, so we might be able to get away with having a full penetration.
Are we going to end up doing more before the end of the dive?
Yeah. We're just gonna do these four here, then we'll go elsewhere for the other ones. Now we're collecting sediment samples. And to do that, we use tools called push cores. They're designed to capture the sediment and then lock it in. Okay, this is number 8.
So does it focus more on this route? Not you, auto. That's all the control over here right now. So if you need to, oh, here. That's right.
Alright, do you want to do a test one or you want to lock full of linear? Probably should test it, right?
Yeah, sure. How do you do a test one?
So a lot of times we'll be asked to just put them all in at once. A test one is just deploying and collecting one before we do the rest of them.
Okay, yeah, do a test one for sure. There's a chance that the rocky outcrop below is going to prevent penetration, but it looks like this area is pretty sedimented. Good news, it penetrated. Is this in love? Is this getting love?
That's wait this first thing again.
More here.
That we're getting more.
More, yes, later on. All right, so we're covered. That's good. This is a rocky area. So we're collecting push cores, which are what we used for studying the sediment and the biology that lives within it. One of the uncertainties is how deep do you go before you hit to something like rock that doesn't allow you to get any more push core. One of our objectives here was to take some push cores next to a basalt outcrop, so there's always the risk of going deep and hitting a rock and not getting a very deep profile of the sediment, but we did good there. So we'll just do this 3 more times, then we'll collect some push cores elsewhere. one of the things that we do to characterize a region is to gain an understanding of the, in this case, fauna that lives here, whether it be sea stars or urchins or sea cucumbers. When we do that, we also want to sample some of the water column to give us an indication of what the water was like, where they lived. It's also important to understand the sediment. The sediment is a location where bacteria live. It's a source of nutrients. And a home for many of the fauna that live here.
The request for these to be collected as close as possible to one another. So I'm not like didn't know about how close you can get, but close enough so that they don't like you know just push for a hole.
Yeah. No, there's basically the limitation to some degree is going to be the physical access to it.
Yep.
So they'll get them as close as we can.
It's good. It's like you make like a diamond or a square, right?
Yeah. That's one of the reasons why I have a lot of potential to do them all at once. Rather than units at a time.
Yeah. Get that one like in between 7 and 8.
Is that between 7 and 8?
Yeah, just get that one really close to some of the other ones. Yeah, one's like a cluster of them. Yeah. Yeah. Yeah, give me a second. Is there a way to zoom out? Alright. Let's get the biggest zoom just so that we see the region. Alright. Okay, give me a second here. Can you put lasers? Yeah, I just want to. Okay, cool.
Yeah, so.
What, the push course? Oh, I don't. Oh, is it? Oh, does it? Oh, right. I see. Oops. Sorry. I'll go get some white out. Yeah, that is.
Yeah, it's still. One thing I got for
I just put it like that. It doesn't really matter. And those guys have the same elevation.
Sorry.
This is your cell phone. Have a nice rest. The computer is with me.
Good morning, folks. Jumping in here for the start of my rotation, or my shift, excuse me. Yeah, for folks confused, we are technically in part 3. If your YouTube says part 2, that's because originally it was named part 2. But it has since been renamed part 3. But I probably will be starting the stream, restarting YouTube here in a little bit. Hopefully it'll kick you over to part 4. We are still on dive 752, visiting the young Volcanics
No, that's an empty one.
here at the Triple Junction.
So that's not a full core. That one's empty. Yeah.
So that core, we think the valve has an issue, so it's nothing in 5. So 5 is not.
Then we, okay.
Yeah. But I think we're logging it as full.
Did you log that one
Okay.
as a core?
Just make a comment or something. Perfect. And then we'll take another one.
Yeah, for sure, for sure.
Oh yeah, it did.
I'm not the one who puts it in the
It exploded, so.
kidding.